So I don't know if you guys, if I sound like a broken record, I apologize. But if I go out on Monday and take a snapshot, all I have to do is look straight ahead of me, and I'll see the horizon. It's just straight ahead of me. Okay. And then if I go out on Tuesday and the conditions are different, I still just look straight ahead of me and I see the horizon. But if I take a picture on Tuesday and compare it to the picture on Monday, the picture not band is, in my opinion. That's how crazy this kaleidoscopic refraction phenomenon is. It changes the entire landscape, but you can't tell with your naked eye. You can't see it. It just looks like it's the same orientation every single time. So if I'm out on the ocean and I just look with my sextant and orient the sextant toward the horizon, it could be farther away, it could be higher up, but I wouldn't know that. It's just oriented at basically straight in front of me. So for some reason, I think it's got that kind of like wiggle room, so to speak. Because all you're doing with your angle to the star is getting the degree to the star. Let's say when you measure the star, it's at 42 degrees. And then 5 hours later, it's at 65 degrees. So you've moved closer to it. No?
Yeah, except the stars are also moving, so you would have to
right.
take a snapshot of it.
That's really interesting. I don't understand how they would address that rotation, the celestial rotation, because that to me that's not even talking.
A very accurate statement. You do not understand how it works. You every time you describe it, you describe it wrong.
Awesome, great. So thank you. So please help me understand, sir.
Generally
you're
speaking,
a fucking troll.
You don't, generally speaking, shoot one star twice. You shoot two different stars, and you have to mark exactly the second that you do it. The only time you shoot a celestial body twice is if it's the sun.
Yeah. Let me ask you a question, Harry. Why did you find it necessary to attack me when you first came in?
Correct you or attack you was correcting.
No. You could have come in and said, "Hey, Travis, I hear you're trying to think this out. You mind if I offer up a suggestion?"
Hey, Travis, I hear you're trying to think this out. You're wrong about it.
No, it's too late. It's too late. You came in. You came in and said,
I told you were wrong.
Yes. No.
Do you want to learn about it?
No. You didn't tell me. Okay, Harry. You didn't tell me.
Okay. All right.
Harry, it's okay, Harry. It's all right, Harry. No, don't come back.
Well, it's funny you want to you'll say, "I don't understand how this works," and then describe how it works wrong, and then somebody will say, "You are wrong. That's not how it works." And
no, that's not what you said.
You won't want to learn how to do it right. At least so you could debunk it. That's what I was thinking.
That's not what you said,
Harry.
Harry.
You want to learn how to not be wrong next time, so you can win the debate.
Oh, okay, great.
For some reason, you have a resistance to learning how it works.
Harry, whether he's wrong or right is sort of irrelevant. Like, if you have something to offer or something that you have to say, then just say it, and then let us know what it is, and then we can all compare notes and go from there.
You're right, Gio. The whole thing is done based on the movement of the stars. So that's why you're not shooting the same star twice typically, but shooting two different stars and marking exactly down to the second that you took the measurement. Because the stars will be moving at 15 degrees per hour. And if you're marking down to the arc minute, if you try, if you get a sextant and try and sight it, or even just open up Stellarium and click on any star and it'll give you its elevation, you'll see that thing is ticking over at quite a pace. So it's not a problem that stars move for celestial navigation. It is a feature. That is exactly how it works.
Yeah, we're aware of it. We didn't say it was a problem.
I mean, you describe celestial navigation wrong each time you go to describe it, Travis. I don't know how to help you with that.
Great. You know what? When I first started having this conversation, I asked anyone to just join in and have the conversation. So, cool. let's try to be
joining in.
Yeah, let's try to be constructive. That's fine. So, okay. So you're saying that you take 2 star locations, and taking those 2 star locations, you are noting the rotation, because the next time you take them. So, how do you determine? Okay, let's say you've got a pretty good wind in your sail, and over the course of an hour, you get a 10-degree difference in. Okay, I don't even know the language. Okay, so you got a 10-degree difference, and then say 15-minute difference. Is that accurate? Is that okay?
What do you mean? You've got a good wind in your sails, and
I mean that you're moving along. You're moving along at, say, 8 knots. Okay, so
right.
So your distance is changing. Your location is changing. So the next time you take your bearing, is that the correct term?
Shooting a star is typically how they colloquially say it.
Shooting a star.
Take a sight a star. Take the angle to a star.
Okay, so the next time
bearing
you shoot a star. Okay, so the next time you shoot a star, you find out that there's a 10-degree difference and a 15-minute degree difference. Is that the way to say it?
No, it's still not how you do it.
Okay, so
you're in one point, and you get the inclination to a star. And typically, the way they recommend to do it is, as you've got it lined up perfectly, the moment you've got it perfectly lined up, you say mark, and somebody next to you clicks a stopwatch to get exactly the time at that. And then you consult the nautical almanac. Well, you probably will do that second. Next thing you'll do is shoot another star, right? Go for Acrux, mark. And now you've got 2 stars and 2 seconds at which they were marked. Then you consult the nautical almanac. The nautical almanac will tell you exactly where that star was over, like where that would have been 90 degrees over. From that information, you can know where the center of the circle is to draw, and how big the circle you should draw on that GP for 2 different places. You'll then draw 2 circles on the map. Right? If you've got a globe, you can do the whole thing on a globe. There's a slightly more complicated way to do it if you're just using a single chart. Then where those circles will intersect in 2 places, but quite often those lines of position or lines of equal altitude will be so big that one of those lines will be in like Africa and the other one will be in Australia. And I'll go, well, I'm not in Africa, so I'm probably somewhere near Australia. You're not shooting the same star, or generally you'll take like maybe 1 or 2 sightings a day, but you're not like continually clocking it every 15 minutes. You get a gist of where you are and then take a bearing and head from there, and then maybe take another reading at night or the next morning.
Okay, so when you have your intersecting circles and you have the 2 points at which they cross, are those vertical or are they horizontal? Are those longitudinal or latitude? Which way do you orient the meeting?
The circles aren't lines of latitude or longitude. They will be, let's say the GP is over New Zealand. It will just be a circle that is perfectly around New Zealand. So it will go over the South Pole. It'll go up to somewhere near Asia. I mean, of course, it's going to depend on the size of the circle. But it's going to be a big old circle, and it's not going to be oriented either vertically or horizontally by your map. It's just going to be a big old circle on a map.
Okay, so are you one of those 2 points of contact?
Yes, if you've shot right, you'll be on one of those 2 points. Generally speaking, that you only need to shoot 2, because you can use pretty good inference to go, I know I haven't sailed 40,000 miles in the night, so I'm not up in the Cape of Africa, you can shoot 3, and then you'll get a bang on X marks the spot cross. You can shoot 5 if you want to be super clear on where you're at.
Okay, so what I hear you saying is when you take two different when you shoot two different stars, and you orient the GP, you then use that as the radius to draw a circle.
The GP will just tell you the center of the circle. The almanac will tell you the GP of the star. The declination, the difference off 90 degrees will tell you how big the circle is. So if it was overhead, it's 90 degrees, and for every arc minute, it will off 90 degrees, you will be a mile from that. So based on that very simple linear calculation, you can go, right, it's at 60 degrees, so there's 30 extra degrees between that. 30 times 60 is, 900 arc minutes, so I'm 900 nautical miles from that point.
Right, so when you came in and Gio and I were talking about the rotation of the sky, right? So that doesn't seem to take any. That doesn't seem to be taken into account. It's just simply the angle to the star. You're not worried about.
Except, I said, I'll make clear. Was it not clear why I said you will say mark the second you took the shooting of the star?
Yeah, like you basically take a snapshot of the sky like each night, and then
kind of, yeah,
track it. But you also have to account for the fact that the stars are also moving, through the seasons. They're moving and they're slightly different.
Okay, so let me make that bit clearer. When you say mark to clock the minute of the star, down to the second, I beg your pardon, that you're sighting the star, that is because the star will be rotating around you at a rate of 15 degrees per hour. If it's moving at 15 degrees per hour, that's 15 times 60 nautical miles, which is, off the top of my head, what is that? Like 180 miles. No, what is it? It's going across the surface of the Earth at an extraordinary pace. So, yes, you need to mark it at that second, because if you get it out by a second, it's moved a colossal pace, and you're going to get it in the wrong spot because the stars/Earth is rotating. So that's why you're marking it to the second. You just generally won't shoot the same star twice because you'll be getting two nearly identical. If you shot the same star twice in close succession, you'll be getting two nearly identical lines of equal altitude. So you're not really going to be able to pick your position off that. And you've got 50-something navigational stars you could be using.
Why do you say that the sky is apparently moving along at a relatively quick pace? What do you mean?
Well, it's like 1,000 miles an hour, roughly, right? It's a little bit.
Yeah, something like that.
Stars are a little faster than the sun, which is.
Yeah, but okay. So if we're talking about general relativity, okay. If you looked up, like last night, I went outside and I saw Orion. Okay, so last night I went out and I saw Orion. I could see Betelgeuse. I could see Beatrix. Okay. They weren't moving at 1,000 miles an hour. They weren't like going zipping across the sky. So that's what I'm trying to understand. Like if I take a reading or if I take two sites, it's not like all of a sudden moved so fast. Like that's what I'm trying to understand why you're using that language.
When you're shooting at that level of specificity, you'll be surprised. So when you look up at the stars of the night, yeah, they look fairly fixed in their position. You've got to use a time lapse to get an idea that they're moving. But the sextant is so accurate, and you need to measure it down to the arc minute, that you find that it's ticking along at a rate of, 15 times 60 arc minutes per hour. So it's that's why you've got to say mark when you do it, because you've got to get exactly the time that you do it. It's my complaint about Kosho's very cool app that he's built in Gem Pandas, and that is when I try to shoot a star with it and then I go to punch in the star, it takes me like, 10, 15 seconds to go acrux and then tap, tap, tap to tap out the elevation of it. And that 15 seconds means I'm now 15 seconds out, because the stars are moving, because they're revolving around us at a rate of once every 24 hours, thereabouts.
So yeah, I'm not sure how this is complicated on a flat Earth.
All of that, I mean, in terms of like shooting a star, getting an angle of elevation, even having an almanac that tells you what that is, all of that's possible on a flat Earth. The issue comes when I know that if I've shot a star at 60 degrees, I know that that is 30 times 60 nautical miles from me. It's a linear distance for an angle. The only way you can get linear for an angle is with a circle. Everything else, it's a logarithmic function, right? If you on a flat surface, if you change from 89 to 90 degrees, that you'll move one distance, and if you move from 0 to 1 degrees, you'll move a totally different distance. So you're not going to be able to work out what the radius of this circle is based on an angle unless you're using it as a linear function.
Right.
Right? Do you get what I mean by that? Like if you're going from on the horizon
I understand.
to 10 degrees on a flat surface, you'd be going hundreds and hundreds of miles. But to get the same 10 degrees at the top, you'd be going a far shorter distance.
Yeah, I understand.
There's many elements to it that preclude being on something flat. I mean, one of them is in order to make these observations, you are assuming that your surfaces, both of the Earth, of the oceans and the heavens, are equidistant from one another. Every time you shoot a star, it's the same distance from Earth. And you treat that distance as infinite. What that creates is two surfaces. If we accept that the heavens are a sphere of the heavens and curved, then they have to map to a curve in order for this, again, this linear relationship or the GPs moving across the Earth at a steady pace. You have to therefore make the Earth curved to fit that.
Or you just let the sky be curved and treat it that way.
Right, but if the sky is curved, the same problem I'm talking about with angles happens. If something's across the flattest part of the dome at the top and it moves, 1 nautical mile, let's say, you'll get close to 1 nautical mile on the ground, but near the edges of the dome, it'll move a nautical mile and you'll get far less change in distance.
Unless there's no edge of the dome. So, like, what do you mean by edge of the dome? Where'd you get that idea?
If there is a sphere, if the heavens are curved and you are sighting things all around the heavens and they all have a corresponding place on Earth across which they move uniformly, then both have to be the same shape.
I don't see that, no.
Okay, so every star has a GP, right? And that GP is moving across the Earth at a constant pace. So if you go heavens moving Earth stationary or Earth moving heavens relatively stationary, both require that they be the same shape. Now, they're not quite the same shape in the heliocentric model. Of course, some stars are closer than others, but they're all treated as infinitely far away to simplify the calculation because it doesn't change anything. The angles.
No. What? I hear you saying that the sky and the Earth have to both be the same shape, but you're not explaining. You're not explaining why.
Because if let me try and think of how else to explain it.
Well, so let me ask you this question. So, on your model of a globe Earth, is the sky a sphere?
For celestial navigation, it's treated as such. Yes.
Okay, I don't know that it's actually treated as a sphere or as a dome. I think the sphere is just simply that same term that we say, Harry's sphere of influence. We just mean like your group of friends, right? So it's just this it's a figure of speech to talk about an area. So
Right. So in
again,
celestial navigation, it is treated as if it's a sphere infinitely far away from you.
but that's not
With
okay.
the
But look,
exception of the moon, which is measurably not.
okay,
You've got to make a correction because the moon is not measurably infinitely far. Like to make that simplification doesn't work.
yeah, okay. So space is not a sphere, right?
Or it depends how you look at it.
No, I don't speak in relativistic terms that way. Is space a sphere? Like if you stepped out, like if you could go outside of space, would it be a sphere? Like in Men in Black?
Question.
What?
I don't know how to answer that question. It's not a question I can make sense of. But
That's because
as I said a moment ago, you treat it like a sphere. But I'm not saying that. I mean, most of the stars we're shooting, at least to my understanding, are within our galaxy. Our galaxy is meant to be, shaped like a flattish spiral.
Okay, great. So when you are when you're shooting a star, and let's say it's at 45 degrees, and you raise your hand and you point up to 45 degrees, how far away is the edge of that sphere?
Are you asking in terms of celestial navigation how it's treated, or how far it actually is from me?
I'm trying to understand where this apparent limit of this. Okay, look. So if I'm in a physical observatory, the ceiling has a specific distance from me.
Because it behaves like a sphere, so you can map it pretty easily back onto a sphere.
Okay. So if we're now in the Truman Show and he was in this massive dome, okay, that dome actually had if it was all symmetrical, every point would be equidistant from him, wherever he was. Okay? So the sky doesn't behave that way. There's no ceiling to the sky. So what's that?
Right. Carry on.
Well, I was talking and then you said something. So what did you say?
No, I didn't say anything. I think I said right.
Oh, okay. It didn't come through clearly, so I didn't know if you were trying to say something. Okay. Again, I don't get the idea of but in your model on the globe Earth, you don't have a spherical Earth and a spherical sky, because the sky in space is just infinite space in every direction. There is no sphere. It would have to be a complete figure of speech.
Yes, that's what I'm saying. It's a figure of speech. It's treated for the purposes of celestial navigation like it's a sphere. You don't treat Alpha Centauri like it's closer to you than Polaris. You just it may be the case, but it is not necessary. So you treat them for the purposes of doing it as if they are all equally far from you, which is infinite.
Okay. So again, I don't. To me, you haven't persuaded me that the flat Earth would have to have or that the Earth would have to be both spherical and the sky spherical. That doesn't. I haven't been persuaded from your argument.
Sure, you don't need to be. I mean, I think that the argument from the nautical miles is stronger. It's measurable. You can do it yourself, whereas this one is conceptual.
Yeah, I don't deny that. I don't deny that. I'm just saying that the sky is creating the apparent movement of the stars.
Right, and giving you a linear relationship with distances on the ground.
Whatever, however you want to label them, it doesn't matter.
Yeah, so Harry, how would that theoretically in your mind work differently if you're on a planar surface with a planar field of stars versus a planar surface with a spherical stars around you?
It would work differently in two different ways, depending on whether you treat the stars as close and local or far away. But both would give you a problem of a non-linear relationship between angles and mile. What that relationship was, like sort of how vast that difference is, would depend on whether you treat them as close and local. But like Brian's example, for example, of saying that the Polaris is basically the radius of the Earth away, will create bigger, more noticeable problems more quickly. It'll appear to work with minimal error bars, right near the North Pole and very north in the northern hemisphere, but it will fall apart because you'll keep going 1 nautical mile per arc minute, but according to the maths, you should be going hundreds. You should be going further and further each time you sight it, and its declination drops a minute. You should be going larger than the last distance you went. Like, there's also the argument for why would it dip behind the horizon, but given that we're talking about celestial navigation, you generally don't shoot things at the horizon anyway. You can throw that argument out and just go, there appears to be a linear relationship between it from 90 degrees all the way down to where you stop shooting it at about 15 to 20.
Yeah, I don't think that's correct.
Okay, based on what? I guess you can do this. You can do this with trig if you want, because you can do trig on, because he's given you a distance like that. You can't do trig with celestial navigation because you treat the stars as infinitely far away. So you're not creating a triangle because there's no third angle. You're creating a 90-degree point at your GP and another angle at your wherever you're sighting from, but there is no third angle. It's in fact more like a parallelogram or something. On his, you do. So you can do trig on it. And you say, right, with a triangle with a height of 39.58 or whatever he puts it at, and my distance on the base is 6,000 or something, whatever you want to pick, what should that angle be? And you'll see that you need to use trigonometric equations which result in nonlinear results.
So
You've got to fit in both warping and refraction and bending of light in the sky.
So the big difference between the two is that on a globular Earth, we don't care about the distance. Changing the distance, like from going from one part of the Earth to another, the distance to the star has not changed whatsoever, really, in the grand scale of things. However, your orientation in space has, because you've changed angle by the globe, by moving on the globe. Well, on a flat Earth, you never change angle of yourself, you only change the distance. So then the angle depends on the distance, and that's why we're getting trigonometric relationships, because when angles depend on distances, you get trigonometric relationships. While on the globe Earth, it's simply your angular rotation in space that determines the angle that's in the sky. That's the big difference between the two.
Yeah, okay, so to me, the wizardry of talking about the stars being infinitely far away is a qualification without any meaning.
It's not that they're infinitely far away, but they're far away enough to where if we move on Earth, the distance to them
is
inconsequential.
Again, that doesn't... Okay. Again, to me, talking about even describing the stars as far away is irrelevant. It's a qualification without significance. It doesn't have any meaning.
Okay.
You even just...
So I can explain the meaning for you if you'd like.
Go ahead.
If something is infinitely far above me and I am on a flat surface and I shoot an angle to it that is 90 degrees and I find that I'm standing right on its GP, what distance would I walk along that flat plane to make that angle not 90 degrees anymore? And the answer is none. There is none. You could walk as far as you want and you would always be on its GP. So
That's
if
ridiculous.
The star is infinitely far away, I know it sounds ridiculous.
That's ridiculous.
This is what happens when you invoke infinity. Things become ridiculous, but that is just the truth. If I shoot
but
it at
that's
90
why.
degrees,
Right.
but
Listen to
I'm on a
what you're
flat
saying.
surface.
Right. Listen to what you're
Yes,
saying.
yeah, Dave, listen to what I'm saying. Yes. If I'm standing on a flat surface and I'm on the star's GP, i.e. I shoot it at 90 degrees and I move 60 nautical miles to my right, I shoot it again, it will still be at 90 degrees because it's infinitely far away. Whereas if it's close, that angle will have changed. So that's why your
Okay.
model will
No,
I imagine,
no.
will require that the stars.
That's absurd.
Let me finish. This is why I'm fairly confident your model will require that the stars be close and local, because
It's
of
absurd.
that. Okay, so test it. Let's test it. Test the maths.
Okay,
Make
listen.
a triangle
Hold on, real
with
quick.
one
Okay.
side that is infinite,
Okay.
and then test any of the other angles in
No,
that
dude.
triangle.
No, listen. I don't live in a world where space is infinitely far away from me. Okay, there's a
That's
star
why.
above. Okay, hold on, please.
Okay.
Okay. So all of this talk about, well, on a flat Earth, this wouldn't work. Okay. The fact of the matter is, we both have the same observation. We both are standing underneath a particular star. It's 90 degrees above us. You go south, I go north, 60 miles or 69 miles, and we both get a degree. Okay? We both have the same observation. There's no reason to start talking about infinity and distance to the star. None.
With respect,
None.
Travis, you have a habit of trying to preclude somebody else from making their point by deciding that you think it's irrelevant. If it's my point to make in a discussion,
Okay.
then it's my point to make. You can rebut it, but I don't think it's reasonable to go. You can't say that. You're not allowed to. What you're saying is you're not allowed to invoke those things. It's not a reasonable conversational strategy, in my opinion.
Okay, great. That's your opinion. Okay, great.
Yeah.
That's your opinion. So it's the same. Hold on.
Treat the stars. You need to know this for the celestial navigation. You need to know how high you're going to treat the stars because of the problem I invoked, which you're right. Infinity.
Can I speak quick? Because you keep talking about infinity.
Yeah.
So you keep talking about infinity as this like insane concept that we should never use, and that's why.
Yeah, it's not real.
Let me finish. You don't have to talk about infinity. You just have to talk about a large distance where the distance on Earth doesn't matter. Like, for example, when I want to describe the distance between me and the US, I live in Sweden. If I want to describe me and the distance between me and the US, I don't care whether I stand 1 meter to the left or right or whatever. 1 meter is inconsequential to this whole thing. That's the same. That's all we're saying is that the distance is so large that the distances you travel on Earth are inconsequential to the final result. That's all we're saying. You don't have to take it to infinity if you don't like that.
Let me respond.
That's what that means.
Okay, just real quick. Yeah, again, I understand what you're saying about the 1 meter moving to the left or the right. I get that. Okay, that makes sense to me. We're talking about degrees in the sky.
Mm-hmm.
That's got nothing to do with distance, bro.
So you can do it if you want to do it. If you're determined that you make it a finite distance, you can, and CellNav still works. It just gets unnecessarily complex. So what you would need to do if you're saying this works on both is show how it works on both, because in the one model, if you do it the way celestial navigation tells you to, which is treat them for the simplification of doing the measurement as if they're infinitely far away. If you can't do that on flat, you have to make them a finite distance away. And then, like Brian found, you have to pick that finite distance. The moment you pick that finite distance, that's great, because now you can do some basic geometry and work out that it's wrong. We can do it. Like pick a height for a star, and we can do the maths, and we can show you where this breaks down. That would be a much more constructive way to have a conversation, because at the moment it seems like you're like fairly confident it would work, but in some ways also resistant to give it a go.
Okay, look, I'm not resistant to give it a go. Would you like to pay
Okay, cool.
for my time off from work so that I could do this?
Do you feel that's reasonable that you're asking now for payment for me to explain
Okay.
something? Is that
No. Okay, listen very carefully because
you've been in
said
this room for a couple of
Okay.
hours yesterday and today, and now you want payment for me to explain to you how this works?
Okay, hold on.
Does that
Geo,
anybody else
hold on.
here?
Hold on. Geo, are you here?
Yeah.
Did I ask Harry for payment for explanation?
No, I
Yeah,
think you asked
basically.
for your time, I think.
Yeah, it was
Does
for
that
my
seem
time.
reasonable?
Harry, hold on.
I don't know.
So
We can work this
Harry,
out, and then he's going to pay for my time. Does that seem reasonable to you, Gio?
Harry, hold on now. Harry. So you've just been corrected, Harry. Okay? I didn't ask you to explain something to me and pay me for it. I said because you said I wasn't willing to do the work. I am
10
absolutely
seconds. We can do it right now.
Okay, I'm driving in
Do
a
it now.
truck.
Pick a height.
Okay,
No, we can do it for you. You just pick a height for a star.
Okay, look. When I discuss this, we're talking about degrees from
Yes.
90, okay? That's got nothing to do about height. It's just a degree in the sky.
No, the fundamental discussion we're having is if you go flat versus round, once you go to flat, you must pick a finite distance. That's the assertion I'm making. If you want to test that, we can test that too. Once you pick that distance, we can do the calculations and demonstrate to you why this doesn't work. Now, you can pick any distance for your star. The star can be 10 foot off the ground. It can be 100,000 foot off the ground. It can be a million feet off the ground. I don't care. But if you pick one, we can do some calculations based on it. But instead, you're doing this weird, like, can you pay? That's not what I'm saying. This weird obfuscation. I don't care that you're driving a truck. Like, we can do this for you and help you understand this. We can help you understand this. Honestly, we can. Okay, so pick a height. We can do this. Go for it. I've got my calculator out.
Why? Okay.
I'll
Why
draw
do
a little diagram. It'll be good fun.
Keep talking. Let me know
Pick
when
a
you
height.
stop waffling. Let me know when you're done waffling. Okay, so you're done waffling. I am not convinced I need to pick a height. Okay.
Okay. So
okay.
So
how about I give you a degree? I'm looking out. I see Sirius, and Sirius is at 27 degrees. How about that?
I mean, that's obviously avoiding what we're talking about, which is noticeable. Like, do you feel that these are reasonable responses when I'm offering to work this out for you to help you understand
What was my rebuttal? What was my rebuttal to you right now?
It wasn't a rebuttal. You just offered to do a different thing. Like either it's finite or infinite. I'm saying it's treated as infinite. If you treat it as infinite, great, but then not flat, because of the reason I mentioned. Every star will be 90 degrees from you.
Okay, let me ask you a question.
Infinitely high above.
But your stars aren't, even in your model, your stars aren't infinite. So I don't know what you pick a height. What's your height you're picking?
That's what I'm saying. For the purposes of celestial navigation, with the exception of the moon, they're all treated as infinite. Even the sun, which is very, very close, right? Compared to
they have to. It's just like with Eratosthenes thing. They have to assume these quote unquote parallel light rays coming in from the stars to make their fake sphere work out mathematically.
Well, you can test it though. Like I think it's okay to make assumptions provided you test them. We're now inviting Travis to test his assumptions. Right, so is it finite or infinite? If it's infinite, right, it's broken. If it's finite, just pick what it is.
Okay, great. So, great. So, hold on. I'm sorry. Just let me ask. I just have a really quick question. So, Harry, when we're talking about people who actually do celestial navigation, do they assign a height to the stars?
They treat it as infinite. They treat the stars as infinitely far away.
Okay, listen to my question, because you're telling me to pick a height.
Yes.
Okay, so are you asking me to do something that mariners don't even do?
No, you can pick infinite as your height. You can do the same thing mariners do.
That's not a height, dude.
Okay, so no, they don't pick a height. They pick infinite according to your view. I mean, to me, that is picking a
You
height.
just said they did. You just said it yourself. They treat them as infinite.
Okay. Infinitely far away, yes. Infinite.
That's not a height.
Okay, fine. Whatever you want. However you want to say it. Do you want to pick infinite or finite? There's an excluded middle here, so logically you have to pick one of them.
No, I don't. That's a false dilemma.
My question is kind of clearing up what the problem is here. I think writing would agree with me. So, ask my question.
Yeah, go for it.
So, essentially, on the globe Earth, we would say the only thing that determines your angle to the star is the angle you are oriented in space. Your distance on any side of the Earth doesn't matter. It's all about the angle you're positioned because you're essentially walking around a sphere. That is the only thing that determines the angle on a spherical Earth. We want to ask you, since on a flat Earth, you do not change your angle by walking the same way we suggest we do. What other mechanism do you have that changes the angle to the star? Now,
okay, well, okay, hold on.
The distance. Okay, go ahead, Ken.
Yeah, I disagree. I do change the degree of angle by walking. So you're wrong.
No, I mean your orientation of angle, not the angle you see the star as, because that's of course demonstratable. But what I mean is, on a flat Earth, no matter what, you're always upright because we say Earth is curved, and therefore when we walk, we change our orientation in space. Well, you say it's flat, so you're not going to be changing your.
Hold on, wait, hold on. Are you telling me that in space there is up and down now? There is left and right.
There's a relative up and down.
What does that mean?
So what I mean is, we can talk about latitude and longitude lines, for example. That's what I mean. If you're at latitude 60, longitude 40, well, that means you have a specific point, a pointing, or you have a specific direction of up in space. While if you're at another one like 80, 40, you're pointing at a different direction.
What?
Not sure if I'm explaining myself with words correct.
No, you're representing La La Land very well. Yes. There is only one up. It's vertical. If wherever you are on the world right now, if you're standing straight up and I'm standing straight up, we are parallel to one another.
Okay. And that's fine. But then I need you to demonstrate what other mechanism do you have for the stars changing angle to you other than distance?
What are you talking about?
You can also test exactly what you just said, Travis, which is if up is up for everybody, then you could use that to work out and triangulate the height of a star, right? Because somebody at some point could clock a star and be at its GP, and nobody else, unless they were standing where that person was, would have that star at their GP. So somebody who is 60 nautical miles away is going to have it a degree off from them, right? So you can know, if I'm on a flat surface, how close that makes the stars.
No, I disagree.
So you don't agree? You don't agree with 1 arc minute equals a nautical mile?
Okay, that's fine. I'll for the sake of argument, I'll give that to you. How does 1 arc minute? What did you say? 1 arc minute equals what?
1 arc minute equals 1 nautical mile. Or
another way to say
it is 60 nautical miles equals a degree.
Okay, 1 arc minute equals 1 nautical mile. Okay, great. How does that determine height?
Because to get that relationship, if we presume a flat surface, let's say they're 30 degrees. There's 30 degrees difference between them rather than 1 degree, which makes it a little bit piddling. So 30 times 60 is 900. Is that correct? I think so. So if there's 30 degrees of declination between them, what we know is the base of that circle, that base of that triangle, because we're on a flat surface, is 900 miles. And we know the angle of the adjacent angle, don't we? Right? It's 30 degrees. We know the other angle.
Wait, you said 60 and 30, right? Wouldn't that be 1800?
60 and 30 is that 1800? Am I crazy?
6 times 3 is 18, right?
Yeah, beg your pardon. Yeah, I said 900.
That's okay. That's okay. Okay.
Yeah,
Yeah.
1800. So you've got a base of a triangle that's 1800, and then one angle that's 30 degrees. Can somebody do the sine, cosine, tan business to figure out what the height of that is?
Yeah, that's all. Yeah, that. Oh, first of all, my rebuttal to that is that's still all abstract. You could never verify the distance. You can work out whatever you want to mathematically.
Can I verify distances on Earth?
Excuse me?
You can't verify distances on Earth?
No, I didn't say that. No, I didn't say that. When you talk about the degree, the 30 degrees, all right? So 30 degrees isn't a distance. So when you bring in this triangulation, that's a mathematical construct. Now, I'm fine with you doing math all you want, great. But you can't verify the physical location of that star to check your work, can you?
That's what I'm saying. That's what we're trying to do. We're trying to go, because we can't verify it, we're having a debate right now about the height of that star, the distance that star has from us.
Yeah, I don't think you can. Okay, I'm going to say it this way: you cannot determine or calculate the distance to a star.
So okay, so you either you need to treat. Either you need to disagree that celestial navigation works, or you need to be able to do this. And even if you might have it wrong, you're like, I've done it for in any case. So
Yeah.
that given that the base of the triangle is 1800 and the angle A is 30 degrees, then A will be 1039 nautical miles up in the sky.
Okay, great. Okay, so you have a conceptual distance. Okay.
You got a distance.
You have a conceptual distance.
You got a distance.
No, because you can't verify it.
Whether you can verify it doesn't change whether it's real.
Yes, it does. No, it doesn't.
What? So if I've got a cat in a box and I won't let you verify whether I've got a cat
whether or
in a
not
box,
things are real is we verify them.
Cat in a box. Like,
okay.
You can be doubtful of it because you can't verify, but that doesn't change the substance of what it is. If I won't tell you what my birthday is, it doesn't mean I don't have a birthday.
Okay, no, this is no. You're not going to be a wizard here. Yeah,
what you're talking about is information that you have, not a thing that is or is not reality. A birthday, you could choose whatever you want to celebrate your birthday. That wouldn't matter.
We've got a conceptual altitude of Polaris, given that we're 1800 nautical miles away from it, and it's 1,000 nautical miles off the face of the Earth. But here, check this out. When I go a further distance from it, so I go, hang on, 15, when it's at 15 degrees, so right on the limit where they say stop shooting things, which will be 75 times 60 away, which is going to be 4,500 now. I hope I'm doing this maths right. Now the height of Polaris has changed. So either this star moves depending on where I am to it, which would make it useless as a guide star, or it's always in the same spot in the sky and we live on something other than a flat surface.
No, that's a false dilemma.
Can you explain why it's a false dilemma?
You haven't. Okay.
Like me saying I've got a triangle that's too large.
Yeah,
it's not a triangle.
Yeah, keep using really bad analogies. So, bacon, or is this gummy?
I mean, either.
What?
Or no, this is gummy speaking.
Right now. Okay, so gummy. Simply dismissing the flat Earth isn't an argument and isn't evidence. It's a false dilemma. So you're saying it can only be one, it can't be the other. No, that's not true. No, it's not true.
If celestial navigation works and these calculations are correct, then it precludes a flat surface.
No, it
That's
doesn't.
what I'm saying.
No, it doesn't.
In what way does it not?
Okay, now this goes back to your begging.
That's a negative. Try again.
Okay, hold on. So, because you were begging me to have a debate with you, and I said to you clearly that I said all of this last night, so I'm going to say it again from last night. The sky is creating the apparent deviation of the stars. I can walk anywhere on the Earth. All I'm doing is changing my distance from one location to another linearly, and perhaps at times even elevation. But all of my measurements to the sky are apparently different because of the sky.
It just sounds like a non-answer to me. I'm not really able to
Whatever,
make any
dude.
sense.
Whatever.
Okay. So the way I heard what you just said is, when you move on the ground, it changes what you see in the sky, which normally has one kind of reaction, which we would say is trigonometric. Somehow the sky does some additional magic to make it linear.
No,
instead.
sir. No,
That's
sir.
what I heard.
Okay, listen. Okay, yeah, listen. Again, there's no reason to invoke magic when we're talking about natural observations.
So then
that's right.
Explain what the sky does in order to turn this from a trigonometric to a linear relationship.
Okay,
what does the sky do?
Okay, guess what? This is where I will not create a story to make up some shit that I can't verify.
Your answer is you have no clue, but it does because you want
No.
You can verify this. You don't need to know the height of the star to be able to verify the relationship between its angular movement and your space on the ground. All of that is within your ability to test and verify.
I didn't say I couldn't do what you just said, okay? This is where you guys have the absurd logical arguments that make, it was like a non sequitur. What you just did in qualifying something had nothing to do with my statement and comment to Gummy.
I mean, it did. That you
it didn't.
It's a different issue. But I mean, you don't want to do something you can't verify. I'm saying you can verify all of this. You can verify
what did I say you can't verify?
Everything from geometry, basic geometry and trigonometry, to grabbing yourself a sextant and shooting a couple of stars.
What did I say you can't verify?
I think you said any of it. Wasn't that the quote?
I don't know anymore, okay? But when you say that I said something, I'd like to know what you're referring to so that we can actually have a honest conversation. So when I was talking with
sure,
Gummy,
an honest conversation would be staying on the topic, and the topic is about the difference between a linear relationship and a trigonometric relationship. How can we make this fit? There are some ways you can make it fit, but it requires that the star move based on where you are.
I don't have to make it
explanation.
I don't have to make it fit anywhere.
Posit an idea, or just accept that this doesn't fit with flat Earth, but other things you believe do. But to pretend like this isn't a problem for flat Earth,
it's not. I'm not pretending anything.
Rant about something is just, and then behave like I'm the one who's not engaging meaningfully in the conversation is silly.
Do you accept that this is a problem for the flat Earth then? That it's something you need to figure out?
Absolutely not. Okay. Absolutely not.
Okay. So engage and show us how it works.
How what works?
Absolutely not.
We're showing you how something works on globe, but not on flat.
It works. It's the same thing. Okay, look.
We're giving you the measurement, and you're saying it works on flat, and we're going, show us, and you're going, no.
No. Listen.
Good then? Is that...
Go ahead.
It's fine. I just wanted dinner.
Mike.
Okay. I mean, this should cover dinner, right? Okay. Let's just do this for now. And
Is Bob Doll hot miking, or am I tripping out?
Yep, I
Bob,
am.
you're hot
There I
miking.
was. Yep.
So the problem I see with this is you're treating the stars as if it's their actual location. Is that what you're doing here?
Treating the stars as if they're fixed points that are infinitely far away is how they're being treated in CellNav.
Yeah, so
And
when
they
you
give
look
you
at them, you're assuming that that the star you're seeing is its actual position in the sky, right?
Actual position in the sky? I mean, yes, I think so, probably.
Yeah. There's your first problem.
Well, what's wrong with that?
But
You don't
can
know
use
if it's its actual
find-
position or not. In fact, we're almost certain that it's not its actual position because we know refraction happens.
Well, that's why you don't shoot stars below 15 degrees.
What we've
You
described.
make control for that.
I'm sorry.
What
Do you think
we've
refraction?
tried-
Hold on. Let's let one. Why don't you pick one guy and then we'll do that. Otherwise,
Sure,
it's going to get too crazy.
All of the manuals say if you can avoid it, don't shoot stars below 15 degrees, or don't shoot the sun below 15 degrees. If you do, you make a correction for refraction. So you treat it as if refraction isn't an issue, and generally at those angles, it's not.
Yet it's still, even in your model, it's still not in its actual position. And for all you know, it might be vastly far off its actual position since we can't go there to verify it, right?
No, that's your model. If you're asking about my model, they are pretty much where they appear to be.
Yeah,
For the purpose of
pretty much where they appear to be.
Let
me restate what I said. Yeah, let me restate what I said. So, and even in your model, they're not in their actual position, right?
Yes.
Excuse me? Why'd you say
we're
pretty
talking
much
about-
in their actual position a second ago, and now you're changing it to yes, they are the actual
Okay.
position?
So because I'm changing between in the entire globe model to specifically celestial navigation, yes, they're exactly in their position.
Okay, and you're in the globe model, they're not though in that position because we know refraction happens, and anything other than 90 degrees would make it cause them to not be in their actual position. So,
what's the refraction? What's the expected refraction at 60 degrees?
it's something which means not actual position.
Right, it doesn't matter as long as it's above 0. That means it's not the actual position.
Yeah, not actual position.
But I'm talking about. I mean, similarly, they're not infinitely far away. But for the purpose of celestial navigation, for the point of a bunch of fractions of an arc second, it's treated as if it's infinitely far away. So if you're asking about celestial navigation, they're exactly where they are.
I'm asking about actual positions of stars, which if that's the case, if you're doing celestial navigation, you have the stars in their actual locations, then you're not going. Does celestial navigation not know about refraction?
Yes, that's why you don't shoot stars close to the horizon. For celestial navigation, you make these assumptions and then you test them, and you can reliably put an X on someone's house if you're good enough at it. I mean, generally it's to within a mile. You can reliably shoot a particular place on Earth I mean, if the stars aren't where they're meant to be, that will be out because it will bend one way on a warm day and another day on a cold day. But that if you shoot stars at a high enough declination or the sun at a high enough elevation, doesn't happen. So it does work. So that's a reasonable assumption to make for the purpose of figuring out where you are on the Earth.
You like to use a lot of words it's not necessary though. So do you think refraction stops when you get above 15 degrees for some magical reason?
I think it becomes negligible.
Okay, that's your assumption, right? I mean, that's not a.
Yeah. How did you eliminate it?
Demonstrate.
Yeah. So there's your first. I'm trying to point out where your problem. I'm trying to point out where your problem is in your assumptions and shit, and it's like you're fighting me every step of the way. Like you didn't know off the jump that this was the assumption that of the actual position and not actual position.
Would you accept, though, Jeremy, I've given like a fairly comprehensive description of how celestial navigation works and can acknowledge that sure, refraction might play a part of it, although I would describe that part as negligible, so you can treat it like it doesn't exist. Like the stars aren't infinitely far, but you can treat them like they are. And I can give a comprehensive explanation of how this fits on a globe. And the only response that I get is trying to pick flaws with it and not actually presenting any kind of reasonable rebuttal or counter model about
pointing out I'm pointing out the problems with it right now. That's what we're doing.
But make it fit on flat. That would break it and fix your
model.
Why?
I don't need to replace. Hold on a second. I don't need to replace
all of celestial navigation, which you won't because you'd have to go back to the history books and tell Captain Cookie doesn't know what he's doing. But even if you broke it, it still wouldn't make a flat Earth. You could still be living on a
Replace
globe.
your bullshit.
You need to make
with
it
my.
fit. You need to make it fit on flat.
I need to replace your bullshit with my bullshit. I can defeat your bullshit and not have to replace it with anything. You ever heard the phrase falsification is independent of replacement?
Yeah, but it's a silly phrase to avoid having a proper conversation.
No, it's a. I know. Yeah, I know. You guys are fucking worthless to even talk to. Go ahead. Have fun with him, Travis.
I think fun is a strong word. Maybe not.
You can list all the assumptions, you can list all the measurements, you can get oodles of angles and distances and stuff to test. But rather than test them, you guys just sort of resort to poo-pooing it.
I'm not sure exactly. Maybe I'm misunderstanding what you're referring to, but I'm pretty sure I've heard literally not a single person here say that celestial navigation doesn't work. Not one person. So I'm not sure. It seems like you're implying that that's the argument when it's absolutely not.
No, I'm not. Well, it certainly sounded like that was Jeremy's argument. That I mean, if refraction were an issue, celestial navigation wouldn't work. So even though he didn't say that, that would be a necessary consequence from what he's saying.
No, I'm pretty sure his argument was that on your model, if you're not taking into account refraction, it shouldn't work. It does work. Ergo, there must not be refraction, or your model is not the one that is actually being used.
Did you say that? Did you ever hear me say that refraction's not taken into account? When I said
was that not your? It sounded like you were arguing against him. That it sounded like you were saying that it was not something you needed to worry about. That would be not taking it into account.
When I said we don't shoot objects below 15 degrees on the horizon, what was your assumption about what I meant by that? I mean, I've said it explicitly, but maybe not recently.
Is everything above that degree 90 degrees?
Is that? I mean, I asked a specific question.
I mean, obviously that's not the case, right? So which means that there must be some shift, right?
Do we take it into account or not? Yes or no?
You tell me.
Yes, we do.
You do take. Okay, so you do account for it. Okay, how do you account for it?
By not shooting below 15 degrees.
It doesn't. Refraction doesn't stop at 15 degrees. There's not this magical point in the sky.
That's what my question was about. Is everything above that degree line to you 90 degrees? Because 90 degrees would be the only time it goes away. It sounds like you're ignoring it.
I haven't calculated it specifically, but I mean, my assumption is it's got whatever the amount of refraction is above 15 degrees, it's going to be less than an arc minute. That's what I'll bank on.
Okay.
So if it's less than an arc minute, and the generally speaking for most sextants they get to within an arc minute, it doesn't matter.
So not the actual position. Stars the stars aren't in their actual positions, right? You're actually making a calculation to account for refraction, or you're not? Wait, did you say you are or aren't accounting for refraction above 15 degrees?
Above 15 degrees, you ignore it. So you don't make any calculations to account for it. That's correct.
So once again, we're right back to you guys assuming that those are the actual positions.
So what would that result in the end result in plotting your position? How much difference would that make, Jim?
Well, what is the actual position? Left lane?
Well, apparently it works because they've been using it.
What's the actual position?
It's whatever you come up with and plot on your map.
Actual position. They're not taking refraction into account.
Well, I would say from all the information I've gathered over the past 3 years, that above 15, 20, say 20 degrees, it is minimal to insignificant above 20 degrees.
That's now your claim, but how do you know? You don't know if that's the actual position or it's insignificant or if it's way off.
Well,
you don't know where it actually is. We just know where we see it.
Well,
are there heuristics you could use to get a pretty good assumption of that? Like you see the star from 30 degrees above one horizon, move at a really steady 15 degrees all the way across the sky. And then when it gets to like 15, 10, 5 degrees on the other side of the horizon, its movement speed changes, and you can use that to make an assumption about how much refraction is being caused without actually needing to go out and touch the star. Would that be a reasonable way to limit the error bars?
Well, just in observations of looking through my telescope, you know, looking down at the horizon at stars on low, you know, like almost straight out across that I could see just above the horizon, they would move so much that I couldn't get a fix on them. They would move completely out of frame, you know, and wobbly, and, you know, that's refraction just like we see it, you know. But when I was looking up in the sky at whatever angle, you know, over 20 degrees, you know, I could get a fix on them and track them across the sky without, you know, they didn't distort, they didn't wobble, you know, so to me that makes sense.
Okay, so you're judging in response to eggshells. So you're judging how the apparent of this object moves at one time to another time the apparent position of the object moves. And you're claiming, therefore, we know which one is the actual position and which one isn't? That seems a bit silly. I know you tried to save him there, Left Lane. That was a good try, but I still managed to remember what I was going to respond to with him.
Well, writing, I don't get why it's complicated to you, why this can't work on a planar surface. I mean, if I'm on a like in a huge warehouse, you know, massive warehouse, and you've got lights on the ceiling, whatever they are. Let's say I can't get to them. I don't know how far they are, but they're there. I see them, and I'm on a planar flat surface, and I'm walking around. I can look at those lights, and I can you know, decipher the GPs of them, because I know when I'm right under one, then that's the GP. You can create a circle of equal altitude, and I could navigate all around that warehouse with these lights in the sky over the planar surface. There's no issue with that whatsoever.
So you could, yeah, you're just going to create a non-linear, a trigonometric relationship to where they are. You could draw lines of equal altitude. You could determine your position in the warehouse based on looking at those lights in the sky. You could stand on the GP of each of those lights in the roof of the warehouse. It's just that for your relationship to the distance to the angle will not be linear. And to go back to Jeremy's point, that could be one way to do it.
It's not true.
Assume steady motion of the star. The other way you could do it is get two people to clock the star and go, hey, that star's just slowed down in my vision when it got near the horizon, and somebody else who's further to the west of you going, well, no, it's still moving at a steady 15 degrees for me. So there's many ways you could test it to be sure of this. Or develop more and more confidence, if you want to put it that way.
Yeah, still, your method doesn't show actual position, no matter which way you look at it. The only way to know an actual position would be what? How do you think?
We don't need to know the position of the star. We need to know its position in the sky. All we need to do for that is look in the sky and it's there.
Yeah, it's apparent position, so not actual position.
Sure, yeah. If it's apparent position we can navigate by, that's great. That's good enough for us.
Yeah, that doesn't prove that the Earth's a certain shape, though. That just proves that something could, you know, the apparent position of the sky lets us navigate by it. It doesn't tell anything about the shape of the Earth.
But like, just imagine that with two people clocking the one star. Let's say it's Polaris, so it doesn't move to make it easier. Two people clocking the one star, navigating by it. One guy, as he goes away from it, it drops in the sky for him. At a like, it loses altitude. Physical distance off the Earth is going down. Yet for somebody else who stays closer to it, it's not. Like, possible, sure, but I mean, how? That's more. That seems like a bigger assumption to make, a crazier thing to think with no evidence than just.
That's why it's not my. That's why it's not my job to replace your bullshit with my bullshit. You don't need to do that. I don't need to do that.
It's not a job to, but I would think you would want to because this this absolutely slams shut the door on whether you.
No, it doesn't.
Flat Earth.
No, it doesn't.
So you'd want to see how it works on globe, and then you'd want to test and see how you can make that fit on flat. And in my
no,
at least
it's
maybe you'll come up with a new model that will. But in all of the attempts I've made to try and see how that could fit on flat, it just doesn't work. But if you treat the Earth as spherical and the stars as infinitely far away, it all snaps into place.
And it would turn the nuh-uh to a nuh-uh, and here's why.
Yeah, nuh-uh, here's why would be awesome, but just nuh-uh is kind of dull.
Are you arguing that the stars wouldn't exist the way they exist if the Earth was flat? Are you thinking that somehow the shape of the Earth would affect the position of the stars?
Yes. Shape of the Earth would affect
the position
of the stars.
That changing the shape of the Earth would move the stars somehow?
Yes. Because you're going to be standing perpendicular to the surface of the Earth, right? So if I put you on a little piece of paper, a little Bob Dole on a piece of paper, and then I bent that piece of paper, the whole world, your whole sky is going to buckle and move one way than the other. If I turn it into a tube and you walked across the curve of that tube, the whole sky would rotate in your view.
Yes, again, this is no, that wouldn't work, and here's why. The sky is the one creating the apparent deviation. That's it.
Based on, but
you could just
is it the sky creating the apparent? Is it the sky creating the apparent deviation? Because it does it depending on where you're standing. So is it really the sky? Is that the variable that's changing, or is it your position that's changing?
Well, if you change your position on the ground, that changes your position for the sky too. It's not like the sky somehow follows you.
Or is it the ground, or is it your position on the ground changing?
Both. If you change your position on the ground, you're changing which part of the sky you're under. I mean, that's obvious, right?
Exactly. I know, it seems very obvious. I agree with you, Bob. Yeah. So if you change your position on the ground and the sky changes to match that, is that really the sky changing, or is that your position on the Earth and what you're looking up at changing?
It's
literally both.
Both.
The ground is changing, the sky is changing. If I move from one room to the other, both the floor and the ceiling are changing.
Great, it's both. Great. So the position on the ground does matter. That's what we're testing. That's what we find out with celestial navigation.
Wait, whoever said that the position on the ground doesn't matter?
Travis was saying it's the sky. The sky is doing that. That seemed to imply that he said that he was suggesting that the ground doesn't matter. It's the ground doing it too.
What?
No.
That's what you got out of his statement?
Yeah,
the thing you're trying to find out where you are somehow suddenly doesn't matter? What?
Here in the dichotomy that is amazing to me, how I see things and how other people see things.
So if it's the sky, Travis, how is the sky doing? Well, I think one of the key things in my mind in this is that you can't, like, it sounds like, Harry, you're trying to define what the sky is. And then you're trying to, in that definition of what you think the sky is, these infinite star distances and all these things, and then you're using that to try to make a model of what you think the Earth is.
Close, yeah. I'm trying to build assumptions to test those assumptions because the ones that lead to reliable results are more probably true.
Okay, but those assumptions, in my opinion, are simply confirmed by your bias. So you have an assumption.
Test.
Okay, you have an
my
assumption.
Bias and my test.
Okay, say it one more time because I didn't hear you the first 3 times.
Great. I have an assumption. Sure, I have a bias towards that assumption, and then I test that assumption and it works. It sounds like what you have on the other side is a bias against it. No tests, just rejection. Otherwise, you'd test it.
Okay, listen. Again, we're making the same observation. I don't make any assumption about anything. I just simply look up, shoot the star, and take these notes. Same thing. I don't have to assume anything about the shape of the Earth or observation, and if you want to call it measurements, they're measurements.
With respect, though, you're saying I do that, but you haven't done that. If you'd done that, you would be coming to us with your measurements, showing us how they fit. But you haven't measured it. You're just saying, "Oh, if I looked at the star, I wrote down those notes." Do it. Write down the notes and test it.
Great. Would you like to commission me so that
You're
I
asking
have
for money
freedom
again?
to do? Okay.
It's like a
How
10-minute
long
job,
do you think
man.
it would
Stop
take
begging.
me? How long would you think it would take me to put these measurements into practice, especially if I have cloud-covered skies like I do right now? So right now,
you want to be paid. You want now. Hang on. Now, do you want to be paid not just for doing it, but for the time you're not doing it, rather than just spend 10 minutes doing it when there aren't clouds in the sky? Like, does this sound like somebody who's trying to learn things, or somebody who's looking for excuses not to? Because it sounds to me like
it's not learning things.
Right.
It's him trying to do your experiment for you because for some reason you're insisting on somebody else do it. I mean, that's a big difference.
I'm just encouraging him to do it. I've done it myself, and I found
Why would he need to test your claim when? Like, what would be the purpose? If I came along and said, "Hey, unicorns are real," and then I said, "You go prove it," like that's just stupid.
It would give you
stupid. But we're having a discussion here about whether celestial navigation works. It seems that everybody in the room agrees that it does. I and all of the other Globers, and even all of the manuals for sextants, the practical navigator, the all of these things claim that it only works on a sphere. And I'm saying you could test this in 10 minutes for yourself and solve for you this big problem about the shape of the Earth. And there's resistance to doing so. It just seems like resistance to finding out the truth.
It's not resistance to doing so or resistance to find out the truth. It's resistance to the premise of that would somehow prove it wrong. It won't. It can't. Because all you're doing is an equation. An equation literally cannot prove reality to you. There has to be a verification somewhere in the process. Otherwise, you didn't prove anything. All you did was write down some numbers on paper.
Don't just do the equations. Test them. Like, particularly if you drive a truck, you can get a sextant. You use an artificial horizon because it'll be difficult to do it near the water. Get a sextant, shoot something, drive your truck to another city, shoot something else, and use it to see if you can plot your location on the Earth. It's a fun thing, a cool thing to do, and it will solve this for you.
Right. Yeah, it's a cool thing. Yeah, right. So I have cloud cover right now, right? Okay. I'm driving right now. So I'm working right now, Harry. I'm earning money right now. In order for me to do what you would like me to do.
I'm not saying you have to do it right now. Nobody was under the impression I was. I was just inviting you to do it sometime. You spend hours per day talking to people.
Let me know
just
when
spend
I
10
can
minutes
finish
of it
my
testing
sentence.
it.
Let me know when I can finish my sentence.
Okay, when I get back from coffee, you can finish a sentence. I've got to go pick it up.
I got to get a sextant. I want one.
Well, they don't call them eggshells for nothing.
But if you're riding on the eggshells, does that really have the same connotation? Does it mean that he's literally he's using the eggshells as the vehicle, or he's on a vehicle riding across the eggshells? I don't know.
Oh, ambiguity. The devil's volleyball. Yeah, I don't think that it would be an easy 10-minute get her done.
If they had actual positions, that would prove it. It'd be all settled. You know, the way to verify it is to verify, are these the actual position? That's what you need to test and verify. Just doing the observation doesn't test anything. You still don't know where the actual position is.
It doesn't make any sense logically. If I have a 1-story building and I paint, like, let's say it has 20 rooms all connected by doors, and I paint every ceiling in every room a different color, okay? I can look at the ceiling and determine by what's on the ceiling which room I'm in. And that doesn't tell me anything about the floor. Every single room could have a different shaped floor, and it wouldn't tell me a single thing by looking at the ceiling, but I would still be able to navigate through the entire building just by looking up. And it wouldn't say a single thing about what I'm standing on. Not one thing. And it would work.
Yeah, I used to use that with the because people would be like, "Oh, all the stars and the moon and the planets, they all looked around." I'm like, "Listen, if I brought you into a room and hung a bunch of objects from the ceiling, I wouldn't tell you anything about the shape of the floor that you were on." Right? Could I stand you on a triangle or a cube or a rectangle and hang, a whole bunch of other shapes, and you would never know.
And like this idea that you can just act as if the star is infinitely far away. What that tells me is that there must be apparently some distance where the distance of the star no longer matters. What is that? How is that a concept they're like holding inside their head and thinking is somehow legitimate? That at some point in distance, there's a point where it no longer matters how far away the star is, so you can assume infinity.
It just has to be far enough. Just has to be far enough away. It doesn't matter exactly how far it is.
Why does it have to be any distance, Howard?
So you could just as easily assume that it's 10 miles away. Is that what you're saying?
Well, all we're interested in is its position above the ground. Right?
That's what I said.
Okay. Yeah, that's basically. Isn't that what Eggshells was saying was a problem? Is if you're just interested in where it's at above you?
It's GP. Yeah, the GP is what we're interested in using the sextant.
But I want to know, do the people here who think that we live on a ball, on a globe, if you can assume it's infinitely far away, could you just as easily say it's 100 miles away and still look up at the star and get your calculation?
Well, that wouldn't work. I don't think, and I'm just shooting off the hip because I really don't know this stuff. But
okay.
If you use the almanac, I don't think that it would work in referencing the almanac to its latitude longitude.
But so no matter what distance you pick to say for the star, let's say you take 10 different people, one says it's 10 miles, one says it's 100, one says it's 1,000. They're all going to be standing in the same spot, looking at the same sky. Why would it shouldn't matter which one of them you get that distance number from, because you're not using that to figure out where you are. You're just getting the angle, right?
Right. So how about this?
Go ahead.
So you have three different people. One person assumes it's 10. Person A assumes 10. Person B assumes 100. Person C assumes 1,000. Person D assumes 10,000. They do their measurements. And then you swap out each value for every other person. So now person A assumes 10,000 and on and on. What changes? Nothing.
Only the distance you assume to begin with. That's the only thing that changes. Everything else, as far as I know, comes up the same, right?
No,
right.
What would change would be the angle off the horizon.
Not from the... No.
It can't change because you're literally taking the same observation with the sextant. That part can't change. All you're changing is the number you assume to begin with, and you're not using that number to find where you're at anyway, right?
Yeah, no, it wouldn't work. I'm seeing just in my brain, I'm seeing all kinds of problems with that as far as like using.
When you assign the value of infinity to a distance, it is meaningless, which means it's not
necessary or important.
It's not necessary. It's negligible. You don't need to take it into consideration. So there's no reason to even talk about that. None.
Well, you use the almanac. You use the almanac to determine the GP, and you use that angle, and you subtract that from your zenith to determine your distance from that GP, and then you use 2 more observations, and you trilaterate to determine your position.
So I don't understand why they
map. You use a key to figure out what a thing actually means. You can go to the almanac, the key, to figure out what a thing actually means to accomplish the task you're trying to complete.
I don't understand why they keep saying infinite. I don't understand why they keep saying infinite distance. Like, even in their model, the stars aren't even close to infinite.
Well, we don't say infinite. I keep hearing that. It doesn't matter. It's just a long way off. I mean, but
yeah, I say treat it as infinite.
Yeah. But they're not infinite.
Right, but same as you were saying about the refraction above 15 degrees. If you calculate and you go, actually treating the 93 million miles to the sun as infinite yields this error bar, then that would make sense. But it doesn't. Right?
Okay.
You can calculate it at 93 million miles, and it's like a hundredth of a fraction of an arc second, which is well below the error bars of a sextant anyway.
Saying
so
treat it as if it's infinite is the same as saying treat it as if it doesn't matter, right?
Mm-hmm.
Okay.
No, not treat it if it doesn't matter. But treat it if it doesn't matter would mean you could treat it like it was 10 foot off the ground, but you can't.
If
you need to treat it like a very long distance.
If you're looking at the star in the sky, if you're getting your measurement, your angle, okay, whether you call it 10 miles or 10 feet or infinity miles will not change what you're looking at with your sextant. So it literally doesn't matter. It doesn't matter what you label it.
Yes, it does.
No, it doesn't.
Well,
it can't. Your words cannot change the physicality of what you're looking at. It literally cannot happen.
Right, but the calculations will break if you treat it as if it's low in the sky, as if it's not infinitely far away from you, but it's like 3,000 miles above your head. That will change the calculations.
Where in the equation do you put infinity? Where is that in the equation?
So in what Left Lane just described, when you know the GP of a star, you know that it is 90 degrees from there. So when he says you subtract it from the zenith, what he means is you're finding the number of degrees around the globe that you are from that point. That if you move that many degrees, sure. So if you move that many degrees, because you know the line from you and the line from this GP are parallel, but yours isn't 90 degrees. So you need to move such that you get that line to become 90 degrees, and you know that it's parallel. Parallel, when I keep saying parallel, that's the bit where you're treating it like it's infinite.
Okay, nowhere in there did you say the word infinite. Where in the equation is infinity input that it would change?
When you have parallel lines. That's where you treat it as infinite. Parallel. Infinite. Parallel.
What? Okay. So
it seems like he's just avoiding my question.
Yeah, I have a question. So if we go to an
here's how to do it, Bob.
Harry, I just have a real quick question, please.
I want to answer Bob's question so he doesn't feel like he's not answered.
Okay, I'm sure he
have an object with a base that's 10 meters wide, but the sides are infinitely long. What is the angle of difference between those sides? Let's say it's a triangle.
That's absurd.
The triangle is of infinite height.
That's absurd.
Don't interrupt me, please. If you have a triangle, right, but the tip of the triangle is infinitely far from you, what are the angles of both of the bottom things, or the two sides of the triangle? Are they diverging or converging, or are they parallel?
Okay. The thing you just asked a question about is something that literally can't exist in reality. So
it can exist in geometry. I'm asking about geometry.
Real.
I'm asking about geometry.
Geometry isn't reality.
Even in geometry, you can't have a triangle with a point that's infinitely far away from you. There would be no way to calculate it. You can't do anything with that because it would continue going because it's infinite.
Exactly. So what would be the relationship between the two sides of this very tall triangle? They would be parallel.
That's absurd. A triangle doesn't have... listen, a triangle does not have parallel lines.
Well done. So let me reason to it from something you can understand. If the triangle's 3 foot tall,
yes,
we would agree that the sides converge pretty quickly. If the triangle were 10 foot tall, the sides would converge but a little bit more slowly. The higher the triangle gets, the closer those lines get to parallel. Once you call that distance infinite, the lines are parallel for all intents and purposes. That's where you invoke infinity.
So it sounds like through words, what you're doing is just lying then. You're saying that they're parallel when they obviously can't be because it's a triangle.
Yeah,
it sounds like you're saying lie about it and then you'll get the right answer. That's what it sounds like.
Yeah,
no, it's saying it is a triangle, but because the triangle is so tall, because it's like 93 million miles in the closest case, the smallest triangle you draw is 93 million miles long. The angle difference between them is so minuscule, it's below the error bars of using a sextant. It's smaller than an arc minute, so it's ignored.
But you claimed that not using infinite would mess up the calculation. And my question was, where in the calculation is infinity used that replacing it with 1,000 miles would somehow mess it up?
Okay, 1,000. Sorry, you go left line.
No, it's just frustrating that we keep going back to that, and it's like it's not being understood. Is what I'm getting.
Yeah. He said that it would mess up the calculation. That means that it's used in the calculation, right?
Yeah, Bob, do you get what I'm saying about the parallel business? Infinite equal
I understand
parallel,
the
despite
words
it being
that are coming out of your
mind-bendingly
mouth. But you're saying two things that aren't possible. You're saying triangle and parallel lines. That's not a thing. That's not real. It literally can't happen.
Right. But you're also agreeing infinity can't happen. So this one ridiculous impossible thing is being invoked by this other ridiculous impossible thing. Now, what I'm next admitting,
yes, we can agree on that.
The triangle is 93 million miles long, so it is finite. All of the triangles you're drawing, even to other stars, are finite, but they're so tall that, like, it's like you're building a house and you go, "How long is this plank of wood?" And they go, "It's 12 foot long," and you go, "Is it exactly 100%?" Exactly 12 foot long, or would you go, it's actually impossible to get any length of wood that's 12 foot long, but for the simplification of building a house, micrometer length doesn't matter. I need to make sure it's like within, a few fractions of an inch, and I should be fine.
False equivocation.
Travis, you have such a habit of just interrupting to
That's because I asked to ask you a question, okay? And you just keep talking. So can I ask my question now?
Evidently, go for it.
Okay.
Was that the question, or you got a new one?
Oh, such a smarmy fuck.
Just joking with you there, man.
Okay, if we opened up an almanac, would it give us a value of distance to the star?
Nah, it's just a bunch of GPs at different times of day.
Right. Okay, again. So again, it doesn't fucking matter. This whole discussion about duking infinity, it is a zero sum. It doesn't fucking matter. All we're doing is plotting out our position on the Earth, taking a degree to a star, which is real and which does work.
I mean, you keep trying to simplify it to that point, but it's like
it is
sort of
that
going,
simple.
All I need for a car is to have a key, and then I turn the key. It's like, but you also need to drive the car.
False equivocation.
Let me read you something from reference.com. Let me read you something
filibuster over. Jesus.
Let me read you something from reference.com.
Can you not spew bullshit?
Let me read you something from reference.com. A triangle can never have any parallel lines.
Yeah, exactly.
So,
but a triangle also can't be infinite, right?
Yeah. So why
it's infinite? It's not a triangle anymore.
This is how absurd you are, Harry. This is how absurd you are. There's no reason you cuss word wizard.
False equivalence.
There's no reason for you to even bring up this stupid anecdote about parallel triangles, dude. None.
Because I'm saying it's not a triangle. I'm saying it's not a triangle. Again and again, it's not a triangle. You don't use triangles in celestial navigation.
My God, then don't bring it up.
Okay, but if it was finite, if the distance were finite such that it mattered, if the stars were close and local, then it would be a triangle. Hey, Travis, can you please let me finish before you shout?
You already made your point before. You've made your point
I haven't.
before.
Hold on, Travis. I want to get in real quick after he says it. Hold on, HL. Travis, let him go, and then I want to go next. I'll be real quick, Travis.
For the reason I stated before, if you treat the stars as infinitely far away, you cannot find a GP of a star
Why are you
on a
yelling?
flat Earth. And then if you treat them as close and local, the linear relationship between angles and distances breaks down. So it does matter how far you treat away how far away you treat the stars. Even
All right.
on a flat Earth.
So listen, you've got 2 points on Earth, and then you have a point in the sky that both of those people are looking at, correct? Yes or no? Okay, so you can make a chord from the GP to the observation point, correct?
GP. Yep. Yeah.
Yeah, that's a triangle, bud. 3 straight lines. Triangles.
Oh, okay. Yeah. On a flat Earth, that makes sense. Yep.
No, on a globe. On the globe, we made a chord.
Where's
you got 2 points. You got 3
angle?
points.
Tell me what the third angle is.
The chord between the observer and the GP.
Maybe I'm not understanding it. It sounds like what you're saying. Hang on, I'll try and draw it.
Yeah, but you just said yes. You just said yes when he asked you the question. First of all, you said yes.
It just maybe it didn't make sense to me then.
It doesn't make sense to you now because we're making a triangle and you don't you're scared of that triangle.
It could be that. I'm just not clear on what you're talking about.
Again, okay, let's go back. Hold on, let's go back again. There's no reason. Okay, look, I've never done these things, but I'm not stupid, so I can follow the discussion. There's no reason for me. Okay, hold on. Let me finish, please. There's no reason for me to attribute.
Okay, I'm going to let you finish. If you continue to let me finish after this, that sounds like a good idea. Let's set that standard.
Great, Harry. Yeah, great, Harry. You're such a dick, dude. Absolute dick.
It would go a lot better if each party would let the other complete their thought.
Cool. I'll commit to that.
Okay,
Travis.
So my point was, there's no reason to attribute any finite or infinite distance. None. There's no reason for you even to say if you attribute a finite distance, because no one does it.
No one does what?
Attributes a distance to the star to get celestial navigation to work.
Okay, so would you agree that it makes a difference whether you treat the height of the star as finite versus infinite? Do you agree with that? It doesn't make a difference whether you treat it as finite versus infinite.
From what you've described, I would disagree with that also. It doesn't sound like it matters at all.
It does. It absolutely matters.
It sounds like all you're doing is changing how you label the thing you're looking at. And when you change a label of something, it doesn't change the thing itself. You can call a banana an orange, and it won't change the banana. It can't.
Right.
No matter what you call it, it'll still be a banana.
But if I call a banana an orange and I give it to somebody who's allergic to bananas, it'll kill them. It won't work. Changing a label doesn't change what it is. If the star, for the purposes of the celestial observation, is very, very far away and you treat it as if it's close, it will break. It won't work. So sure, it's just a label, but it's a label that has an impact on how you do the calculation.
That's what I'm saying. It sounds like it doesn't break it. See, it sounds like whenever you use a sextant, you get the angle, and no matter what you call the distance to the star, it won't change what the angle is. The angle will still be the angle.
So let me ask you the question then, Bob Dole. I measure the star that's at 60 degrees inclination from me, so 30 degrees declination, 30 degrees off due north. How far do I go to get to that GP?
I don't know.
Did you? My bad, go ahead.
So there was one correct answer to this, and it relies on this one assumption. So it does matter. Either you don't know the distance to that GP at all and are unable to work it out, or you can because you're treating as if it's infinitely far away. And like, we can do the maths on this rather than arguing about whether it matters. We'll do it. Like, make a triangle.
Did you figure out how the globe is making a triangle yet with the chord?
I don't know how many times to explain this. The celestial navigation on a globe doesn't use triangles.
But you can make a triangle out of this observation. Do you understand that?
Describe to me how. I don't understand what you're saying.
You have 3 points. You have 3 points: the GP, the observer, and the star. Correct?
Right, but
okay. What
I said before is important here. You're treating it as if it's infinitely far away, which makes the lines parallel. Once again, can you have parallel lines?
Oh my God! Stop! Get this guy out of here.
I thought we were going to let people finish their statements, and now he just interrupts to shout.
No, I didn't.
Can somebody mute him?
I did not agree to that.
Of course, you didn't agree to that because you're a child.
Listen, how about this?
The question's to Jeremy.
I got it.
Jeremy and I are having a conversation. Travis, shut your fucking mouth.
hold on. I have
Jeremy,
an alternative.
can you have a triangle? Jeremy, can you have a triangle that is infinitely tall?
Okay, I'm trying to walk you through how to explain and show to you how you can make a triangle out of your observation. And you're trying to fight me on the triangle you're making.
Right, but what I'm pointing out to you is this. I've drawn an image. I'll put the second one in the chat. We're trying to get the angle from the observer, but one of the sides of the triangle is infinitely long, breaking it. It's no longer a triangle because it has two parallel sides. So if it's got one right angle and another line and another parallel side, it definitionally cannot be a triangle, can it?
So you don't want to know how you're making it. So you don't want to learn how you're making a triangle. I understand.
Defer to elbow.
That's fine.
Defer to elbow. Elbow. Does a triangle have parallel sides or not?
I understand that you don't want to learn how you're making a triangle. That's fine.
Thank you. Okay. So if we're making a triangle, the height is finite. If we're not making a triangle, if the height is infinite, we're not making a triangle. So
you managed to totally obfuscate off the point I was on. Thanks.
No. The point you were on is that it's a triangle. All I'm invoking is that a triangle must be finite.
Okay, great. So here's my counter offer. I will.
I don't really want to hear it, to be honest. You interrupted and filibuster.
Yeah. I will work on not interrupting you. If you work on not making
Travis,
hold on, let me finish my offer. I will.
No, but I just want to wrap this up with him. I don't have long. I got all kinds of family stuff.
I got the gist of what you're saying, Travis, and I actually think that's fair because I have been a little bit snarky too. So yeah, I will make a commitment to that if you make a commitment to not interrupt.
Sounds good. You guys can kiss and make up. So now that I've explained, you have 3 points, right? You have a GP, the star, and the observer, right? That's 3 points, right?
Yep.
You can make a straight. You're making in the sextant measurement. You're making a straight line to the star. Then from the star, you're making another straight line to the observer, right?
Yep.
And we know there's a chord. You're on a globe, right? So there's a chord going in between them. That's another straight line, correct?
Okay, hang on. Let me finish. Let me keep drawing.
This is the part that's going to hurt. I know.
Cool. I think I'm with you so far. Yep, go for it.
Yeah. So we have 3 points and 3 straight lines, right?
Sure. So
yeah. Guess what that's called?
A triangle.
Yeah. That's great.
Yeah, that's what you have. You have in your sextant measurement. You can calculate a triangle out of that measurement.
You could, yes, I would agree with that. You could calculate, but that's not how.
And triangles don't have parallel lines, right?
So just to clarify, you could
triangles
make a
have parallel
triangle out
lines?
of it. You could make a triangle out of it, but that's not how it's done.
Do triangles have parallel lines?
No, they don't.
But we know we can definitely make a triangle out of this. Right?
So clarify what you mean when you say that. We can make a triangle
3 points,
out of it.
3 straight lines, a triangle, bro.
Right, but we don't use a chord through the earth. So we don't.
But you can do that.
Like
that is possible to do, right?
We don't use a chord through the earth, and we
I
also
understand you don't use a chord, but it's there nonetheless, right?
What
is
do you
there
mean
a chord between the observer and the GP?
To me, this is a little bit like I drew a diagram and gave it to you, and you drew extra lines between different points on it and said, "See, it's actually a cat." And I was like, "No, I drew a house." Okay. Like, yeah,
in reality,
sure, you can add lines and make a cat out of it, but that's not how it works.
Okay, 1 second. You do have 2 straight lines from the observer to the GP, from the observer to the star and then the star to the GP, right?
Observer to the star and the
star to the GP. Those are 2 straight lines, right? 3 points, 2 straight lines. We know that, and you're doing this on the globe, right?
But
dude, come on, these are easy yes or no questions, bro. I only got 2 minutes. Shut up, Left Lane. Shut up for 1 second. I only got 2 minutes. So
is this what you're talking about, Jeremy?
Bro, I don't know. I'm not looking at no screens. Can you not visually see this in your head? There's 3 points. I think I can.
That's why I'm drawing it to check.
Okay, there's 3 points, and you already have with the sextant measurement 2 straight lines. You're doing this on a globe model. We know the globe model. You can make a chord, which is a straight line from the observer to the GP, correct?
Yep.
Yeah, there's your triangle.
Okay. Sure.
So, what's the significance of it?
Yeah, it's a good question. Jeremy, the question was, what's the significance of that triangle?
You're trying to tell me that these are parallel lines you're making. Yeah, I just showed you how you can actually make a triangle out of it, which means you can't have parallel lines, right? The significance is it debunks your whole argument of parallel lines. Duh.
Like if you make the distance to the star finite, it goes back to being a very, very, very long triangle. I've said that a number of times, but the angular distance between them is far below the error bars on a sextant. So they are parallel. So I can make this super clear. They are treated as parallel.
But they're not parallel. You're treating a lot of things that like they're not, or they might
Treat
be.
the distance like infinite, and it makes the lines parallel, which fits within the error bars of the thing and simplifies it. Yes,
but they're not actually parallel. And when you do this on a globe, you can actually make a triangle out of it, right?
Yes, yeah, you can make a triangle with 93 million mile sides.
Okay, cool. So that's not parallel.
You think back when like ships were more of a common way to travel, and using this to navigate was more common rather than using electronics and stuff. And this was a big deal for people getting where they're trying to go. You think that they actually used infinity in their calculations, trying to figure out how to get to where they're trying to go to?
So I can say this like super clearly. You don't put infinity into the calculation by treating the lines as parallel. That is effectively what you are doing. So yes, that is exactly how it has worked since they first made sextants, even arguably before that. Even before they knew the distance to the stars, they were using this when they still held to a geocentric model of the Earth. They still did it the same way because it worked. What we've come to understand is a bit about like how it works based on like mean sun is one of the things that they didn't first understand is my understanding. The fact that the sun isn't always at its zenith at midday. It's sometimes 15 minutes early or late, depending on the time of the year. But like, basically, yes.
Okay, so
man, that's a beautiful story, though, man. It's just a bunch of you hear.
That's why I cut it.
That's hearsay. Sorry.
Okay. I mean, if you disagree with celestial navigation, sorry, Travis is trying to speak. Go for it, Travis.
Go ahead, Travis.
That's part of the reason why I jump in sometimes, because everybody just can talk at the same time. So I don't understand on your second picture there, Harry, why you have two parallel lines.
Can somebody else have a crack at explaining it? Because I've tried to a few times, and if it's still not working, then I have limited reason to think I could with a.
Okay, so let me. Okay, you treat it as parallel to get done what you're trying to get done, from what I understand.
So to clarify, you could treat it as a 93 million mile triangle. It's just you'd get a result. You'd make the maths more complex, and then you would find that there was no point in doing it.
Would it make it more accurate?
It'd make it more accurate by like a sort of.
That's what I would think.
Hundredth of an arc second.
The margin of error is so small but that technically means that if you don't use infinity, instead you use an exact number, that would make it more accurate.
Yes. Yeah.
Okay.
Okay, so am I to understand then the 2 points that create your vertical lines is one point the observer and the other point the GP?
Yes. Yeah.
Okay, so that works on a flat Earth. They're both parallel. Yeah. They can be both parallel on a flat Earth. What would be required is that the stars are treated as if they are infinitely far away. No.
My question is, what's that line cutting across the Earth?
That was me trying to understand what Jeremy was saying. That's not what's used in CellNav. In CellNav, it would be. I mean, I can show you what it would actually look like in CellNav. Would be just a second. Like that. Hang on, I'll post it in the chat. You draw a line of equal altitude. So is it your assertion, Travis, that it would still work if you were on flat? Would you treat this? How far away would you treat the stars?
Okay, why do I have to say this again? There's no reason to attribute distance to the stars at all.
So maybe I'm misunderstanding you. Here's my reason I think it would matter. I'm going to draw a flat object, right? And then I'm going to say, this is, here, I'll share my screen so you can watch me in progress. I know you're in a truck, Travis, but driving, sorry, now I'm still talking about trucks. If that distance is there, but these lines are all, do you do that for parallel lines or do you do the arrows? I forget. You go that, and that's to a GP of a star. If you're treating those as parallel and somebody else is shooting that same star, they will get the same GP there. Similarly, if a star's over here, like, well, it's going to be infinitely far, so it's obviously not going to be on the thing. If you're getting a declination of
90s, bro.
Yeah, if you're getting a declination of 30, if it's infinitely far away, it will also be a declination of 30 over here. So you won't get, if you're shooting that star, the declination won't change based on movement. If you're shooting that star, the declination won't change based on movement. So that's why my assertion, at least my understanding, would be you have to treat the stars as something other than infinitely far away. Because if your star's at 90, if Polaris is 90 for you, it'll be 90 for everyone.
Okay, so in general, I disagree with your explanation of how you think it would work.
Okay. Do you want to?
The GP is 90. You got the GP of a star. It's 90 degrees, and then you got the observer. Let's say the observer's looking at shooting a star, and it's 45 degrees, right?
Mm-hmm.
You think those lines are parallel? A 90-degree line and a 45-degree line?
No. Sorry. The lines I'm talking about is, let me just, two different
the lines
stars,
to the
right?
star, from the GP to the, what's that?
So these lines are parallel, right? So are we talking about what's on my, oh, right, okay. So which one are you talking about then?
I'm trying to figure out which lines you think are parallel.
I just explained.
First of all, he has a flat face.
I just explained it, Jeremy. So you are the observer, and straight above you is a vertical reference. So that's 90 degrees. When you get the degree to a star and drop down to get its GP, that is the other parallel line. It's straight down, 90 degrees.
I just had a thought. Would it make it easier if, rather than keeping on invoking infinity, which I gets sort of confusing and sounds ludicrous.
Not confusing.
Would you like? Okay, sorry, it sounds ludicrous then maybe. Would you like that I do the same calculations? We do the same calculations, but I do it on a 93 million mile away sun.
I want you to. I want to know what distance. I want to know what the when you add the chord to this measurement. I want you to add a chord and tell me what the distances are you're coming up with to these stars. Because you are getting a triangle, right, with the chord. Remember, 3 points, 3 straight lines.
It's kind of what I'm offering to do. I'm offering to say we can start with a 93. Like, for the purposes of CellNav, it's infinite. So if I did it from the ground, the number would just be infinity, because
not 93 million miles. Not 93 million miles. I want you to get the angles with the chord and the lines you draw for your sextant measurement, and then from that calculation find out what the distance is to the star.
So we can do that. Let's go with Polaris. Okay, we're going to shoot Polaris. Based on flat or based on globe? Which would you?
In reality, bro. In reality.
Well, you have to do it.
I don't know.
You have to pick one.
Yeah, you've got to pick one. Otherwise, you can't do the calculation. You can't even start.
The globe model. I want to know when you draw the chord. Right, we're going to make a chord in this one, so you're going to need, you're going to come up with a distance. Triangles work, right?
Okay, but I'm not sure how else to say it. Like, if I go back to that diagram I drew where the two lines are parallel, and we drew that chord line back between them, that angle and that
angle. Those lines weren't parallel. There's a chord in between them. That means they're not parallel, and they're going to one point in the sky. It's a triangle, not parallel lines, bro.
So what do you, can you say again what you're trying to ask me to calculate? Like, start again, forget the business about the chord, because the chord's kind of confusing me. What do you ask me to calculate, and I'll do it?
I think he means the distance, to calculate the distance.
Sure. So, like, Let's do it. Let's just do it. So I'm going to do it on Polaris.
You have the distance of the chord, and you have the two angles, right? The angle from the observer and the angle from the GP to the star. You should be able to figure out how far away the star is from both people.
Right. So are you looking in chat? Are you able to for a second?
No.
You're not able to.
So how do we know the distance of the length of the cord, the distance from the GP?
You know the length of the cord because your globe model will dictate it. Right?
Yeah, we can know the length of the chord. The angles are going to add up such that it's not a triangle if I do it based on celestial navigation.
Not possible. Not possible, bro. You have 3 points, remember? The observer, the GP, and the star. That's 3 points. You don't have parallel lines.
Yes, but here's another way to describe it. If I continue that line down and continue that line down, that angle is going to equal that angle. So, and to add this, that therefore this and this is going to equal 180 degrees. So what I'm saying is, if I tried based on this use of cell nav, I'm not getting a triangle. What I'm getting is a parallelogram or something like that.
We know there is a triangle there, right? Because we got 3 points.
Right. And I don't know how else to describe this.
Hold on. Can I ask a question?
If we treat it as if it's infinite, we don't end up with a triangle. So we can't calculate the height of something that's not a triangle, because it's not a triangle.
You do end up with a triangle, though, because you have 3 points and 3 straight lines in between them all. That's a triangle, bro.
So what I'm offering to do is we can turn it into a triangle, and I can calculate the height for you based on that. But it's not currently a triangle.
It is a triangle. You have 3 points and 3 straight lines. You know what that makes? Do you know what happens when you have 3 points and 3 straight lines?
You want me to treat it as a triangle? So you want me to stop doing celestial navigation and go back to like basic Euclidean geometry? I can do that, fine.
I mean, you have a triangle there, your chord and your 2 observer points.
Right, but I don't know. I mean, I can just keep repeating it. I can put it on like one little soundboard. In celestial navigation, it's treated as if they're parallel, so it's not a triangle.
I know, but they're not parallel.
I know.
I don't know why you're treating them like they're not when they are. Or
because
when they are, when
the
they're
difference
not.
Between because the difference.
My wife said they're perpendicular. She doesn't know what she's talking about, though.
Right, she's wrong. If it made a difference, if it was within the error bars of the sextant, like the moon is. The moon, you can shoot the moon to determine your location. In fact, you can do some cool stuff to figure out the time, but you don't treat the moon as if it's infinitely far away, because it is such a close distance that it is within the error bars of the sextant.
I don't. Are you making up excuses why you can't get the distance of the stars or with this triangle that we have?
I mean, explaining it to you, if that sounds like an excuse, then yes, I am.
All right, whatever.
Like we can, I want to re-offer to go back to the idea of calculating the height of Polaris. So if I'm on the North Pole, and we're going to treat for the sake of this, Polaris is in the dead center of the North Celestial Pole, and then 30 degrees latitude.
Why don't you get an actual measurement and that way we don't have to make shit up like Polaris being directly over the North Pole and shit.
Oh,
I think they can't.
It circles around it. I mean, if you like.
That's what I mean. If you get an actual GP of the star, if you get an actual sextant measurement, we won't have to make anything up. All right?
Okay, fine. I'll find out how far it is off. 45 arc minutes, 3/4 of a degree off.
I don't know why you would want to make shit up. Can't we just Google it? An actual sextant measurement.
I mean, for the same. I mean, sure, we can do it. I mean, if you want to, we can find a location. I mean, you can also do this in a rudimentary way on Stellarium. Like, I mean, it can be a fun way to go about it.
Yeah, I was actually going to ask you to do that.
Sure. Okay. So, for anybody, can everybody see the whole screen of Stellarium? Because I was also thinking a fun way to do this would be that I blind where I am. I move my location in Stellarium to somewhere, but not, I don't know how to do that, hide where I'm at with it. Yeah, I can just stop sharing my screen.
I don't care where you are.
Okay. So fine. We'll go to, where's somewhere interesting to be? Africa.
Just go to Virginia. Just go to Virginia. It's dark right now.
Fuck, you're going to make me zoom in and then admit I don't know where Virginia is. Is it near Washington? Is Washington near there? That's Chicago.
It's close enough. Yeah, go anywhere on the East Coast. Just go anywhere on the East Coast right there. Just drop down to even Chicago. Chicago's in the dark right now.
Sure, okay. So Chicago, we're going to go to Chicago. Use this location. Why doesn't it let me? Oh, that's right. I got to drag the pin. This is stupid. So you get this, drag it over there, plop it about there, zoom in. Hey, that was pretty good. Bang, it's on Chicago. We'll use this location. Now we will get oh no, of course you're not going to be able to see Acrux from there. What are the nav stars? Blender chart, is it? Blender chart, or does he have a special thing for it? Does anybody remember where Kosho's thing is in Bible Study Purgatory? No, I think it's going to be in Blender chat.
Can you change the time of the night?
Sure, yeah. What time do you want?
Go to like 11 o'clock at night. You'll have Beetlejuice.
No, sorry, I won't, because I can't change the time of Kosho's thing, and it's long and laborious to do it without an app to help. Unless you really feel that it's important to, then I guess I can do it just with the almanac rather than his automated almanac. Yeah, where's that? The bot room, that's it. So I go, and then somewhere up here there is a list of what the stars are. There we go. So is Arcturus one of them? No. Capella. Oh, hang on, this isn't in alphabetical. Hang on, Polaris should be there, shouldn't it?
Well, if you went to London right now, you could get Beetlejuice and probably Sirius, because that's going to put you 5 hours 5 hours ahead. So just go over to Europe.
Just a sec. Temp Polaris. No, it's okay. We can do it from here. Temp Polaris. This is how much the time matters. You can see that thing ticking up there, and I go down here. Get that out of the way. Good. Jump to present. Dot temp Polaris, and then we go as alt is what we want. 41.24. Oh no, that's closer to 50, isn't it? 21. I'm going to go about that. What's happened to it? Oh. He's changed it, I think. Sextivus? I think he's changed the command for it. Just a second. Polaris. 41.48. What the fuck is the... Polaris not one of his stars?
Dude, just go to Europe.
Oh, his whole thing actually tells you all 3 stars. No, it's not about where we are. It's just about how I use his thing. Sex to us. Okay, we're going to do Polaris. Is it 41, 48? I'm going to do, even though it's at closest to that. Then I'm going to do. This is going to be a bit out because I'm not going to be able to get them all at the same time. Arcturus. That in his list? Yes. Arcturus, and that is at a 5413. He's updated it so it can now draw these 3 circles. And then third one can be Procyon, is that there? And Taurus, we have that. Yes, it's below what we'd shoot in reality, but we can be safe with this one. And that is... No, I actually shouldn't shoot it that low. Sorry, this is taking ages. I don't know the names of any of your... My excuse. Boom, serious. Okay, we'll do that. 0, sorry. Below the horizon as well. Deneb, gotcha, is 837. 37 is going to be like 60. It's not, oh my God. Okay, we're going to have to do it a different way. People can talk amongst themselves while I sort this out, but Kosho's app's for some reason not responding to me at all. Copy exactly his command from before and see what that says. Automated, what's it called again, the book that you use? The Almanac.
Almanac.
Love that it goes up to 2025. Okay, 2022 compact. Wow, okay. So now I go put that over there. Get that there, put that up. And we can basically the same thing again, really. So what I've got open is this, so people know. To be honest, I'm struggling now with the almanac without Akosho's app to help me.
Well, then you really know you're in trouble.
Yeah, the almanac's hard. It's just like, I'll show you a page of it. Just like a wall of text, and I think I've got to do the calculation to figure out exactly that time of day, based on like when it rises and when it sets, and then dividing that into 15-degree hours.
What is it you're trying to do right now?
Use Stellarium to pin a location, and then show how you use the celestial navigation to figure out where you're at.
Mm-hmm.
Sounds like you need a Sexton Simulator game.
I just use the app because it's this bit's really difficult. Which is my next thing to challenge to accept. Oh, hang on, there's an app. Awesome. Okay, now I've found an app to do it. UTC date is 11:44.
But I'm just asking, what's the purpose of this? Just to see if you can do it?
Yeah. Well, I've done it before, but admittedly using the app. Okay. So I got an app to do it. So I've got Vega at 12:45 UTC time, and it is 21:25. Bang. Second sighting is going to be maybe Arcturus. I think that's in the list. No, it's not. Do Procyon. However you pronounce that one. And that is at 18:56. Calculate. So next I plug these into Google Maps. Convention is for this. Yeah, just do it in decimal. Okay. 70.55 is going to be 90. $128. Dot. Right, so that's going to be the GP of the star. Now I need to draw a circle around it. It is so sweaty here in Australia.
It's a weird brag, dude.
What the fuck is going on now?
Whee!
Why is it?
No, I thought it was funny.
That was good. Why is it doing this?
Maybe not.
What?
So that star was dead over somewhere in Russia.
Riding, would you say that you question the globe Earth?
Sure. Like overall, whether it's spherical, not so much anymore. When I first started the discussion, in bits, yeah, in parts of it. Possibly a little bit when I first was questioning the moon landings. I probably did a bit like, if they didn't go there, is it real? Is up there even real?
And somehow something has confirmed that it is all of a sudden?
Well, lots of different things have confirmed that it is. So that's the thingy. And then if the declination was 38, 48, should be able to go 38, 48. No, just 38. 60 equals that. Plus 48, which is going to be that many nautical miles. I think I'm doing so many steps here that there's such a good chance I've stuffed this up. Oh my God, it doesn't give me. What's the miles to nautical? Every step of the way. Circle, bang, 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 bang. Okay, so there's one that should, no, I'm obviously way off there, aren't I? Because that line should go through Chicago, so I've done something wrong. Try again. Ah, that's what I did wrong. Okay. GHA and the declination with a lat long of it. More maps.
Hey, what's up?
Yo.
How are you guys doing?
Oh, I'm struggling, I tell you what.
What are you trying to do?
Save us.
What are you trying to do?
I'm trying to get heightened declination of stars to do celestial navigation, but Kosho's app's broken, so it's taking forever to, like, you know, find.
Oh, you want the position? Yeah. Oh, I can. You can use Stellarium to do that.
I've got the position of the stars. I'm just struggling to turn that into GPs and circles on a map.
Oh, right. So if I'm not mistaken, the declination. I mean, 0 hours of declination is 180 degrees of longitude. What coordinates do you have?
The coordinates I think I have for this are 3848 north and 2449 west.
Where did you get it from?
Out of a app for the GP of Vega when I shot it good 15 minutes ago now.
Right, it gives you the GP in latitude and longitude?
No, it just gives it, well, the app gives it to me in Greenwich hour angle and declination.
Right. Yeah, so if I'm not mistaken, to get from the declination. Oh, one sec. I might be. Yeah, the right. Does it give you the right ascension and declination?
It gives me the app gives me the Greenwich hour angle, declination, and height of the observed.
Right.
What do you guys?
Or you can check that in Stellarium.
Yeah, trying to do it. Well, yeah, I've got it from Stellarium.
Well, if you want to be sure you're in the right GP, just put that coordinate into Stellarium and look up. Oh, the web version is much more limited. I don't think you can. I'm not sure if you can set your coordinates there. If you have the app installed, you can do much more.
Oh, can you? I didn't know that.
Yeah, the web version is like a.
Oh yeah, you need to get it for the phone, dude. It's the shit.
I mean, the desktop app has it all.
Yeah, the app is so great on the phone because you can look at. It's so cool, man.
Yeah, unfortunately, I don't have my computer.
Let me try and get it there. You just start from the beginning again.
Maybe view settings, and in view settings you might be able to set your coordinates.
Degrees and minutes. Oh, that's what I'd also had wrong. Okay, I was trying to do it back into decimal time. It's meant to be degrees and minutes. So 08, 09, 09, and that is at 0151. Second sighting. Okay, got one. Need a regal. Yep, I'll just do regal for the second one. And that's going to be 4 minutes, and it is 58, 42, 4 minutes and 19 seconds. Calculate. Regal is.
What exactly is this for?
Just to show how it works, but mainly because I want to learn how to do it.
Right.
48, 3 minutes and 5, 10 seconds. Calculate.
What do you have, an almanac?
You can't stop you can't freeze the time on Stellarium, or can you?
Not sure.
Well, I know you can do this on the app. I'm not sure.
Yeah, I don't think that's the bit that's going to make it simpler. It's just then when I've got the numbers, trying to punch them into something that'll draw a circle on the Earth, I think is where I was going wrong. But I'm just going to go again. Procyon is right now at 25.01. And then the next one I'll do can be Sirius.
Look, there's a satellite there. Can you see it? Like, There's a satellite there.
No, I'm missing it. Well, it just won't do it now. Just giving me the app's just giving me an error. It worked once and now it's stopped.
Yo, Eggshells, I was going to ask you, do you do voiceovers?
I used to.
No shit.
Commercials and shit, yeah, films.
No kid. Did you ever do anything like National Geographic or anything like that?
I did nothing nature. I did like a couple of documentaries I voiced, but one was like
really
for an artist, some Indian
fucking
artist.
right. No, dude, I swear to God, I like, and I did not look you up or anything like that, dude. Forgive me. You know what I mean? That's not my style. But I was listening to. It was funny. I forget what I was listening to. It was something on like fucking Netflix or I don't know what. Man, me and my girl were sitting there listening to something, and I was like, "No fucking way." I said to myself, I was like, "Babe, I was like, this sounds exactly like this fucking guy I was talking to," and I was like, and I was thinking to myself, like, because I'm of the opinion that like flat Earth is such an enigma to society that they are sending in people to find out what the fuck flat earthers are about and write articles about them and shit. And I don't know. You seem like an esteemed gentleman who would be capable of doing such a thing. That's so cool, dude. That's so cool. Forgive me.
Oh, thanks, man. No,
Yeah,
it's very nice of you to
I
say.
can only
Yeah,
wonder
I
if it
used
would
to
take,
speak really differently, and then got like when I did a theatre course at uni, it started and like the like it wasn't really about acting, but the lecturer kept being like, "You mumble." I spoke not mumble, but just didn't enunciate very clearly. And then, particularly after going to India, I was like, people just can't understand me. So I'd like put a lot of effort or sort of time into practicing to speak super clearly, and then I love doing voiceovers after that.
That's so cool. I wonder. I'll have to if I come across it again or whatever it is. I'll see if I can like cite it so I can tell you and be like, "Was that you, motherfucker?" Like, I was my theory. I ever tell you the theory about how like because you know how the daytime starts in Australia. You know, like the day officially start right if I'm not mistaken.
Yeah.
So it's like you'd have like people from Australia speak like 1,000 miles an hour. You know what I mean?
Yes.
And then
Barely open their mouth and speak really quickly.
and so my theory was, and then you get all the way over to England and they're still speaking 100 miles an hour. You get over to New York, they're at a little bit slower maybe. And then by Cali, they're slowing down. And then by Hawaii, it's just like, hey, man. And then, it starts all up again. And like, when it hits Australia. People's voice and their quickness of their words. I always felt that was funny, By the time you get to Hawaii, it's all slow.
Yes, I also wonder that if it matches with like the pace of life for people, because you go out to the country and people talk like with a drawl. It's like real ochre, and
Right
mumbled, but quite slow.
Yeah, I've heard
Things just happen when they happen.
Yeah, that's cool.
Does Stellarium give me the GP of a star? Because maybe I could do it a different way, like without the almanac and all of that. Just
it does. But I think it gives you the GP, but not in the celestial sphere, but in like the viewers. Like if you use the observer to establish the spherical coordinates, it gives you in that coordinate. But there's a conversion you can make. You just have to get the timestamp and how many sidereals they. How much of a sidereal they passed since those two spheres last aligned to correct for the longitude. I think so. Maybe there's an easier way to do it. That's the way I used to do it.
Couldn't you like pick a time and then like find the location that a particular star would be at its zenith, right?
yeah, but it could be at its zenith, but like that not be 90 degrees.
Well, no, but I mean, like, check it out. If you pick a location, or forgive me, like a time, like a snapshot of time, and then try to put yourself at a sub, I don't know what that point would be, a GP, I guess, right? Right under the star.
Yeah, you can play with their location and match the star to be exactly vertical.
Yeah, what are you trying to accomplish?
Just trying to use
that
Stellarium
difference
to show how CellNav works, but give Kosho's
the difference is the timestamp it's being used. Like one is instant, the other is J2000, I guess, which is like a specific timestamp in which that would be the GP of the star. You know, not the GP, but the celestial coordinate of the star. So you just use the current one. The J something one, yeah, you can see there's. Probably that's for the desktop app. Yeah, that's not the GP, because I guess that would change over time. Maybe
it should be changing. Azimuth and altitude, kind of, but yeah, I don't know. Well, because I've got the almanac open, but I haven't done this with the almanac yet.
What year is the almanac?
2022.
Oh, okay, cool.
But it is just an offensive wall of numbers, and I don't quite know yet how to turn a specific reading at a particular second into GP. You know,
Fuge knows how to do it. Are you on the counter spacer?
Yeah, if you pick the point of Aries,
send us an invite.
Pick the point of Aries, if I'm not mistaken, and I think that's where you want to, like, or pick one of the navigable stars, and look up.
I've got like Arcturus. It's just that Kosho's app used to give me both GP and you can work it out, but size of the circle. I just need to know GP. I can work out the size of the circle given the nautical miles. Okay.
So that right ascension and declination is their position in the fixed celestial sphere, right? So, and the GPA of the star is going to match its own coordinate when once every sidereal day.
Right,
Sorry?
Right. Yeah, when the ground lines up with it, I was saying.
Exactly. So you can find like the closest timestamp in which that happens. That's how I used to do it. I'm pretty sure there might be an easier way to do it, because I don't think you can use the web version to do it. So there's got to be another way.
Hmm. Verging on giving up, which is embarrassing because I don't like giving up.
Oh,
thank God.
If you install the web app, I mean the desktop app, I'm sure you can do it.
You reckon?
So what is your what's your position, or like, you know, in your azimuth, what's the elevation of Arcturus where you are?
Where I am?
And I'm always amazed at how low, or not, or forgive me, like, you know, you think of South America, like southern, below the equator, you know what I mean? It's going all the way to the 60s and whatever. It's crazy. Australia's only in like 34, 32, 30, somewhere in that range, right? Latitude. I was just wondering the elevation of Arcturus from your azimuth, in your azimuth.
From me, it's saying near Sydney, it is 53, 54 below the, so negative 53, 54, so below the horizon by a fair way. It's also weirdly saying the sun is, which doesn't make any sense.
Below the horizon for you. Would it have already set?
Daytime, it's clearly not. Say again?
Oh, I guess you know what? It's probably setting for you because it'll be coming up for us. I think at some point, if I'm not mistaken, on the ecliptic here.
No, it's just there's just something going weird now because it's got the right. Oh no, hang on, it's got the wrong time. So it is 10 p.m.
Isn't it like noon for you?
Yeah, it's doing it for 10 p.m.
So right, so it's set for you, and it's actually would be rising for us. If it does it, I forgive me, I don't know. I was looking up a little bit of it about, but I'm just it's got to come up to above our horizon. Does it not?
Yeah. Sorry, 10 o'clock at night it'll be below the horizon. Right now it's at 5 degrees 31 above.
Right on. How cool. Yeah, for
I
us,
just had the wrong time set.
Right.
That could have been what was wrong with my calculations before. The time was wrong.
Right on.
Because I'd set it to local time and I thought I was setting it to UTC time. So I put it out by 10 hours and then was like, why are my calculations off? Can I be fucked starting again? Or should I just do my editing now before my girlfriend gets cranky at me?
Hey, can I ask you to do something real quick on it?
Sure.
Can you click the box to show the celestial equator?
Yeah, sure. The ecliptic, you mean?
If that's what you want to call it, sure.
Well, yeah, so just put on the meridians, like activate all the lines. And that shit is so cool to me too. You know, because it shows you your own azimuth, like, you know, or your zenith, and then it shows you the celestial spheres, you know, pole points. Fucking cool. Like the Earth is flat. You can describe it well as a ball.
Okay.
Let me know when you get the ecliptic up.
Yeah, got them both up.
Okay, so where does it place the ecliptic?
Places the ecliptic. I'll just get rid of the meridians. I know. Yeah, like bang in the middle of the sky overhead. Real time.
What constellations is it going through?
Let me show the constellations. It's going through Cancer, Gemini, Taurus, near Aries, Pisces, and Aquarius.
So that's not the ecliptic.
Is it not?
It is not.
Okay, let me check again. Maybe I've clipped something wrong.
No, you're not. Celestian is wrong.
Stellarium's wrong.
Or Stellarium's wrong. The celestial ecliptic is Orion's transit. Orion rides the ecliptic.
Well, Ryan's right above it in this, pretty close to it.
Well, it's not that it. No, let me say this again. Based on my 2 weeks of shooting the night sky, Orion is the ecliptic. He's not near it. He is the ecliptic.
Well, I've just Googled it and it just says Orion lies well south of the ecliptic and only happens to lie. So even Wiki's wrong on that one then.
Yep.
Is that red line the? Is the red line?
Sun, man.
The red line
Yeah.
is the
So
ecliptic and this is Orion.
if the sun was to pass above, was to cross horizon, or Orion, then Orion would be one of the zodiac constellations, because that's how they were picked. The zodiac constellations are the ones that the sun passes through. And
if you put on the grid pattern on this stellarium, like activate like all the grids.
Yeah.
Like, and it'll show you like that's how, there's your lines of rotation. You know what I mean? There like those lines of like latitude headed outwards are going to be your rotation thing. Anyway, that ecliptic is just the sun, if I'm not mistaken.
Right, I see. So that's
why I said
standing.
Exactly.
Right, but
the other one's the celestial
sun is
sphere.
going to appear to move from 23 degrees like north of the equator and 23 degrees below the equator. So the ecliptic is kind of always back and forth.
That's why I said the celestial equator.
Right. Okay, yeah. I guess that wouldn't be the ecliptic then.
Celestial equator and the ecliptic are like they're off by how many degrees? I forget.
It only goes 23. Well, throughout the year, it's 23 degrees on each side. If I'm not mistaken, because you're coming up. You know what I mean? That's summer and winter. That's what's great.
What's Stellarium's tick box for? Is it for the ecliptic or for the celestial equator?
No, it shows it all for you.
Ecliptic.
Stellarium is so great, bro.
It doesn't have one for the celestial equator. Sorry, I misunderstood what you meant. When you say celestial equator, you mean if you drew a line out from the Earth's equator to where it hits the celestial sphere.
You can find it by the number of zero, like the 0 degrees on the lines of latitude on the celestial sphere, though. Right. So it's there.
Yeah, so I see. I'm going to post the image of the difference between the two. Yeah, I'd misunderstood. I didn't know the difference between the two, but they're out by a fair amount. So there's a good chance that Orion is on the celestial equator.
Right, it probably holds the middle point or something like that. Like
he rides right between the northern and the southern rotation.
Right, but that's not the ecliptic. Well, yeah, it's interesting. That's what's so. I mean, this shit is wild. But yeah. The moon is interesting too, because I think it only goes like from 5 degrees. Like, doesn't it like follow this? Like, follows the ecliptic never more than 5 degrees off of the ecliptic, whether north or south of it. I think, if I'm not mistaken. The that's a whole other level of shit.
Current time UTC up. I'm going to try this one last time, and then I'm going to give up.
I understand we're watching Stellarium. What are we looking for or at? Or
I'm trying to do celestial navigation and I'm taking forever. We are so far from when the captain turned to me and said, "Hey, Private Harry, figure out where we are." Seaman Harry. He's now currently debating throwing me overboard, I think.
That's fair.
He's like, no, what I want you to do is narrate our demise.
Yeah. You're obviously no good at this. So
That's funny.
oh,
You know, it's
my
funny.
God.
I used to always say how like Rumpus was always the type of guy that you would just like lock him in the cabinet with the maps and the numbers and just tell him we've got to get from point A to point B. And he'd do the math, but you know, just never tell him why we're going anywhere. You know, just do the fucking math and that's it. Okay, just stay in there. Everybody's got their place on this ship, you know.
Hey, Issa.
Yeah.
Can you strum Everlong by Foo Fighters?
I don't know Everlong by Foo Fighters. You know what they're working on though? You better come on into my kitchen, 'cause it's gonna be raining out, dog. Better come on into my kitchen, 'cause it's gonna be raining out, dog. Sit out in my room. Some joker got lucky, stole it back again. You better come on into my kitchen, 'cause it's gonna be raining now, dog.
Eggshells gave up?
Was that?
Pretty close to it. Pretty
Right.
close to it.
Well, I was doing the math to get the triangulation after you get the 3 coordinates and the 3 distances. So if you still want to do it, this might be helpful.
Okay.
Said I woke up in the morning, realized, yeah, it's flat.
You got a wicked voice, man.
Oh, yeah, you're gonna love this song. Hold on, one second, check it out. Said I Woke up in the morning and I realized the earth is mine. But then I went round telling everybody, and I'm not quite sure I should have done all that. I said my baby thinks I'm crazy. Mama doesn't agree. I said my baby thinks I'm crazy. My mama doesn't. And now every time I go to town, they're all laughing at me. I said I woke up in the morning and I realized that. I said I woke up in the morning and I realized the earth is flat. But then I went around telling everybody, and I'm not quite sure I should have done all that. He did some crazy right, mama died. I said my ladies think I'm crazy, but my mama got me. Now every time I go to town, everybody laughing at me. Laughing at me.
Observers 3225. So
I liked it. That was good.
that was great.
Cheers.
You got a great voice, man.
Thank you, brother.
Nah, still fucked it. I don't know what I'm doing wrong.
The shape of the Earth.
Maybe it is. Maybe it's flat. Oh, hang on. Ah, that's what it is. That could be it. No, still missed it by a mile. Maybe Earth's flat. Maybe that's why it doesn't work. It cannot be user error, so it must be the shape of the Earth.
You're almost there, Eggshells. Almost there.
Oh, doesn't feel like it. Skip that calculation and test it at the end. 30.
Mm.
Doing that bit right. Right. I'm doing something else wrong. I don't know. I got to do some work though. Oh my God, that's what I'm doing wrong. Okay, I found another problem. Seven.
Hmm?
Did you guys hear about the two? What was it? They were like college swimmers, and they were like two trans athletes that met in the finals.
Oh my God.
And like I guess like one of them was way better than the other one. Blew him out of the water, I guess. And like the Golden Globes or something, like the best female actress was some tranny guy. Feel bad for women these days.
Yeah, I cannot imagine what it'd be like to train and then step up, like finally get to go and compete, and you just see somebody there and you're like, oh.
Dude,
I
I
guess
can't
they won't
believe
win.
there's a fucking MMA fighter. There's a fucking MMA fighter that fights in the females. Was a dude. Is a dude. Fucking and like
Yikes.
cracked like this chick's skull. Brutal. You're real low. Whoever's trying to speak, I can't hear shit.
Yeah, it sounded like somebody was about to say something. Then. Yeah, it is bizarre to me. It's like I get the idea of inclusion. I'm for it, but I'm like you can't just sort of deny. It's like denying maths. It's like you can't like a performance enhancement. If you want to enhance performance, man or woman, what do? Inject testosterone.
Inject the thing that men make way more than women, like every single day of their life.
Yeah,
You know,
it's
like
so
think
bizarre.
of like your poor innocent, like somebody's little baby girl
Maybe
going up to fucking compete. She fucking worked her ass off, and some buff dude is gonna. Whoever's speaking is so low, man. We can't hear you.
Is there someone speaking? I think you might
I
have
think
something.
someone just hot
else
mic.
playing.
It
You know
sounds
what?
to me like just hot mic.
Forgive me.
Master Chen says, stop your fighting and have a cup of tea.
Are we still waiting on Harry?
Is that eggshells? Is his name Harry?
Yeah.
I think he gave up. Maybe. Does seem a little bit off for him to say it's something that you could just settle yourself by just taking a few minutes to go do, and then it doesn't seem like he can even do it. So like, couldn't he settle it for himself? Shouldn't he settle it for himself first if he's going to make that claim?
Trying to make that
you can settle
triangle
it for yourself.
Is he still trying to make that triangle?
Yeah.
Really? Wow. All right. Good for him. I mean, it is a triangle. You have 3 points and 3 straight lines. So I don't know. I thought the whole point was I thought he was trying to say the lines were parallel.
They're treated as parallel, Jeremy. Okay? You pretend
as
they're
actual
parallel,
positions,
and then you can make the calculations or whatever.
Yeah, and they're also treated as actual positions, which they're not. I mean, there's so many assumptions in this. I don't know. Sure, it works and we can navigate by it, but that doesn't prove that.
Right.
What it actually
Basically,
is, or something.
I mean, if I put up little lights in my room here, and I memorize which shapes are in which part of the ceiling, I can navigate by it. Whether I say that they're 1,000,000 miles away or 10 feet away doesn't really matter. I just need to know where I'm looking, basically, to know where I'm going. I can still navigate by them.
If there was some weird shit going on in between you and the light, it could make it look like it's a curved surface, when in actuality it's just something happening with the light or the way the sky's working.
Yeah.
That's one of the major. That's a huge assumption.
But if there was something weird going on between me and the lights in my room, that would be factored in when I make the system of navigation to begin with, because that's what I would have seen when I was going to make it.
See, they do the same thing they do with Eratosthenes, but there's a guy that did Eratosthenes on a flat surface, and he got all the points to match up to where the light source was, just like they do on the globe. And they say, well, if it was flat, if it was actually flat, all the light sources would match up. But we get different positions on the sun or whatever. With the Eratosthenes thing, we know the sun's not in multiple different locations. However, if you were triangulating a reflection, that's neither here or there. The point is, they got it to the Eratosthenes thing to actually work on a flat surface. All they did was change the medium in between the light source and the toothpicks. You know what I'm saying? So, because something looks like it's working in a linear fashion or not, doesn't mean that that's actually what's going on with the ground.
You just don't understand, Jeremy.
Maybe
not. I know.
Hey, check this out. Tell me what you guys think about this. I don't know if you guys have seen the Star Trail videos that I have, but I have about 6 or 7 Star Trail videos. And I set my cameras up side by side because my first night that I shot, I just set up and I thought, well, I'm just going to shoot Polaris and then I'll shoot to the south. So when I got the files the next day and started looking at them, conceptually, when I was looking at the Polaris footage, and then when I looked at the southern footage, I was like, this doesn't match. Like, even though I was looking at 180 degrees, I could tell that the sky wasn't symmetrical. So I said, okay, well, the next night I'll take a side by side and make a panorama, right? So I'm gonna overlap the right camera and the left camera in the center. I'm gonna overlap them so I can just line it up, right? Does that make sense? Hello?
My bad. What'd you say?
Are you serious?
My bad, bro. Say it again.
You want me to say the whole? You want me to say the whole thing again?
He's zoned out looking at a crypto chart. Just go ahead. Go ahead. That was only a couple seconds, right?
Okay. I set my cameras up side by side so that I overlapped the right frame of the left camera and the left frame of the right camera so that I could just line them up side by side and make a panorama. Does that make sense?
I'm with you.
They don't line up. There's like a 30-degree angle change in the stars. Okay?
You're trying to make a panorama of a moving thing, though, right?
Yeah. But they have...
It's only moving in a circle, though, so it doesn't matter because the circle's not actually moving.
Okay. But the point is that when Orion moves from the left camera off camera, it should just pick up where the right camera is. Pick right up and keep going in the same line. It doesn't. It drops down to a dog leg by about 30 degrees.
Are they the same cameras?
Yep.
At the same angles? Like they're both.
Yep. So I did this for like 6-7 nights in a row. And I went out, I did, star trails. It takes about 2.5 hours to shoot the star trail. So I'd get up every 3 hours and just switch the cameras to the next part of the sky and follow Orion.
Did you have the same zoom and everything and all the same settings on it? On them?
Yep. Yes. So the one thing this is beside the point that I'm making right now. That's one thing. So I would encourage you to go check out my channel and go check out my Orion playlist.
You got a YouTube channel?
Are you serious, dude?
I'm just fucking.
Jeremy, you got a YouTube channel? What? Like you haven't been shilling it for like the last 10 years? No.
All right.
Maybe not.
Okay, so listen. So here we go. So the other thing that I came to propose by looking at Orion, Orion, as I said before, rides the celestial equator. The northern celestial rotation is above Orion. The southern is below Orion. Orion is the buffer between the two celestial rotations. So we're told that the reason why you have two celestial rotations is because the Earth is spinning. So if you're at the equator, you're not going to get deviation because you're right at the center. So it's going to make a straight line, right?
Yeah, but that's not what happens, though.
Okay, hold on.
All right.
My point is, if it's because the Earth is rotating, then every latitude should have its own celestial equator. It's not going to be one single constant equator. It's impossible.
Oh, yeah. Why does that even... Hold on a second. This is a good point right here. Why does it happen at the equator? It should happen anywhere you go. They should be diverging if that's...
That's right. Yes. That's absolutely right. So here's my other challenge is, anybody out there, I think I said this to Charles Flat Earth Math when he was on my channel a couple nights ago or a couple weeks ago, whatever. I said, you find a student in your school that has a science project, and if he can model a globe Earth and create two celestial rotations, I'll pay him $250.
Don't they blame this? Don't they blame that convergence and divergence at the equator on like perspective or something?
No, as far as I know, it's only due to the rotation. The reason why we have the only thing that can create two celestial rotations is a spherical Earth.
No, I know. I'm talking about the divergence and convergence at the equator that we see with the star trails. That should be happening on all the latitude lines, you said, right?
That's what I'm saying, yeah.
Yeah, don't they blame that effect on what's their excuse for that effect on why they convert?
I don't know. I've never heard anybody address the point that I'm making. I've only ever heard We can only have 2 celestial rotations because the Earth is a sphere. That's all I've ever heard. I've never heard anybody say anything about perspective with what that does.
Because people have brought this up a few times with the convergence and divergence of the star trails at the equator, and I've heard it blamed on perspective. I've heard it blamed on something else I can't remember. Oh, maybe the wide angle lens, but they got them with rectilinear lenses, and they're still convergent and divergent, I think.
Yeah, so my point is that if the Earth were spinning, you would never get 2 celestial rotations. You would only ever have linear trails everywhere you go on the Earth. It would always only be linear. Everything would move in a straight line.
I'm going to have to see what their excuse is for that convergence and divergence at the equator. Because that was a tough workaround for them.
Yeah, don't give them too much. Just try to ask it as general as possible. Like, just say, like, why do we get that? Like, and see what their only reason. If they only say one thing, then they can't, default and say, oh, well, it is this. You're like, no, you didn't say that first time. Now you're qualifying yourself.
Because if it was perspective only, then you'd see that at every latitude, right?
Well, I don't think I'm going to blame that on perspective. That's just going to be physical location. If you're at a physical location, you're going to have the stars deviate based on that location. But if the sky is the only thing in motion, then the sky is what's creating those 2 points.
Yeah, I hate basing the shit on what the sky is doing. It's like it's unverifiable. When you're doing shit to the stars, dude, if you did the thing with the lights in the house, if you put these lights on your ceiling, right, and you were like, yo, I'm going to go just by judged off what these lights are doing and the angles to them and how they move and shit, you could be like, yo, the floor I'm walking on is either flat or curved. The difference is you can go to the light, you can know the actual position of the light. You know that the medium in between you and the light.
This whole thing is a Saint Nick fallacy, okay? If you create a story about a guy who gets around the entire world delivering presents, you're going to have to build a story to support his ability to do that. So all of your major premises depend upon all of your minor premises depend upon the major premise being true. Okay? So if you start to propose that the Earth is a globe from the get-go, then every physical observation in nature that you come across after that has to be back engineered into the globe. Right? So when people first observed the celestial rotations, what did they attribute that to? Right? Like how many, like if you had people in China, okay, the people in China, they only figured out the Earth was a globe because ships went over the horizon. They didn't figure it out because of the celestial rotations. That was the Africans. They figured that out, but they didn't figure out that the Earth was curved because boats went over the horizon. And then the Greeks only knew that it was this way because they were Eratosthenes, but they never thought about the so like nobody ever figured everything out on the same point, right? The thing is, the whole, like if you go back to Copernicus, right? If Copernicus is the origin, let's just say, if Copernicus is the origin for the Earth being a globe, then Newton's going to come along and go, bro, physics, that doesn't work with physics, right? Because water doesn't conform to the exterior of a shape, bro. So then you have to make up some fucking magic power that keeps the water to the Earth, right? So everything depends upon the major premise, which is why I always try to push these guys and say, what is your model's major premise? Where does it begin? When did it begin? Because everything after that has to get back engineered to fit. So if you think that the Earth is a ball, and then you come across the celestial rotations, you're like, fuck, how are we going to get out of this one? Well, that could only happen if the Earth was spinning. Okay, so make a small model of it and show me, because that shouldn't happen. That should not have to depend on scale. You should be able to create star trails in 2 different orientations on a small model. No problem.
Hey, have you heard about something called miraging?
Yeah, I think so. Pretty sure, yeah.
Never heard of it.
Just messing with you. Just messing.
I like when they say miraging can only happen at if you're at a certain altitude.
Yeah, it's so stupid.
That's weird. Like if you're looking higher, you're not going to be looking through the. You're still going to be even on a globe or flat. You're still going to be looking through like a weird dense layer of atmosphere that's doing something nuts.
Yeah, they say the stupidest shit they can't back up.
That is just a silly claim right there. That the altitude you can only have a mirage at certain altitudes. Well, same thing. He tried to do some crazy shit with me earlier, saying, "Well, refraction ends at 15 degrees." No. Maybe it's less. Maybe it's actually more at that degree. You're just reverse engineering it off the globe model.
One of the things that I want to prove is the celestial horizon, that 15 degrees, is because the extended plane is out there, so that kind of like when you see the sun go down, right? If you see the sun go down, apparently it's at the horizon. But if you extend the plane out farther, then it's like the compression thing with perspective and compression, right? So if you look at a chessboard and you lower your perspective, the back 2 rows are going to get compressed. And so if those squares are 2 inches square, then you've got 4 inches of depth that gets compressed into a 1/4 inch of space. That 1/4 inch of space, or whatever, however you want to measure the degree, right? Whatever arc seconds you want to put on that. Which is why Rumpus and Ruhif can't understand how such a small degree of angle in the distance can block objects. Okay? My point is though, when you look out into the distance with these observations, these long distance observations, and there is that very obvious aether band that is above the horizon. You can see a dark band above the horizon. That's the extension. That's the extended plane in the distance. So that degree of angle could be 50 more miles beyond. So it's not that it's not the atmospheric horizon. That's the actual horizon in the distance. It's a little bit abstract to think about.
Oh man, we can't be judging shit on this visual stuff, because now that now that we know we're not seeing in straight lines.
Maybe not.
What's up, Bob?
Well, I don't agree with that, but that's just me.
Well, I mean, if you're going to judge where the stuff is, you're going to need to know it. You're going to need to know what the straight line is to it, where its actual position is.
It's where it meets your eye, Jeremy. If you look straight ahead, if you go out to the I don't know, a lake near you up in Albany, go out to a lake, you look across the lake and you can see a house. It's right there in front of you. That's all you need to know. In my opinion.
Maybe not.